All right. 1, 2, 3. Right.
Mhm.
Let's see notifications. hmm Muslims attack Jewish soccer fans in Amsterdam. hmm hmm So they attack the Jews in Europe and they tell them to leave Israel, Palestine, and go back to Europe. But when they go back to Europe, they attack them there too. So that's kind of weird. That's I don't get it. So I thought this has to do with the Palestinian people. They need independence. Oh, so I thought you'd be more inviting. You tell the Jews, hey, go back to Europe so that the Palestinian people can have independence. But then when they go to Europe, they kill them or whatever, they attack them. Nevertheless, yeah. Very nice. Very nice. Very, very nice. Anyway, it doesn't make a difference. The whole issue has nothing to do with anything. It has to do with poverty. The Middle East is poor. Poor people are violent. Poor people are. That's it. I mean, you want to create violence. Make sure people are poor. You don't need much more than that. You want to make people happy. Make them wealthy. Theoretically, the Middle East should be the wealthiest on the planet. There's oil in the Middle East. But no, unfortunately, the Middle East is very socialist. Islamic countries, unfortunately, are Muslim, and Islam is very socialistic. Unfortunately, regardless. So that's the issue. Israel happens to be just another poor country in a very poor region. So that's it. Anyway, let's see what else we got. So I was just listening to Sean Carroll, a 4-hour podcast. I just went through, I think, the first hour. He's saying there is no um the crisis in physics doesn't exist.
They sadly indicate why it is hard to move beyond our current best understanding, because indirect evidence is very, very limited in what it can
Let's go back a little bit.
nature of reality is a quantum field theory. The low energy, visible nature of reality will still be very well described by quantum field theory. Even if it's strings or loops or triangles or whatever at the deepest level, quantum field theory at the effective level will be valid below the ultraviolet cutoff. And that's exactly what Fermi had stumbled upon. His theory is valid up until you get to the scale of the W boson, which is 80 billion electron volts, which is way higher than they had access to in the 1930s. That's the good news. The bad news is the same news. The same phenomenon that makes effective field theories so effective at low energies, and they're the theories that we test at the Large Hadron Collider, etc., makes our questions about what goes on past the ultraviolet cutoff very, very difficult to answer. Because unless you literally build a particle accelerator and smash particles together at scattering energies higher than the ultraviolet cutoff, your effective field theory is going to give you whatever answer you want. It's going to give you the answer you need. It's going to give you the correct answer. Okay? So there's a phenomenon called decoupling. You can very easily imagine that there are high energy processes, heavy particles, new symmetries, new forces, discrete spacetime, whatever you want above the high energy ultraviolet cutoff, and you can't tell. You can't distinguish between any of those possibilities just by doing experiments at lower energies. And by lower energies, we mean lower than the highest energy experiments we've done. Several trillion electron volts now at the Large Hadron Collider. So effective field theories are great because they help us describe the world very, very accurately. They sadly indicate why it is hard to move beyond our current best understanding, because indirect evidence is very, very limited in what it can possibly tell us. And direct evidence is very expensive to get. You have to build a giant particle accelerator. Anyway, that's a very important part of our story because that's an important part of why physics right now is having trouble making wonderful, fast, dramatic leaps in progress in fundamental physics because effective field theories are making it too accurate to describe the world right now at the energies that we have access to. Okay, let me zoom through the rest of the story I want to tell you about contemporary physics. So it's not just quantum field theory. That's obviously the centerpiece of everything, but there are particular kinds of quantum field theories. Quantum field theory, as we see it manifest in nature, does have that pleasant property that sometimes shows up that if it's allowed to happen, it seems to happen. The standard model of particle physics seems to do everything possible that we can think of a theory to do, maybe other than supersymmetry, which is a separate question we'll get to later. But the first step is gauge invariance, okay? You may have heard that the standard model of particle physics is based on this idea of gauge invariance, gauge symmetry. And it goes all the way back to electromagnetism, to Maxwell, really. But let me say what gauge invariance is in a more modern language, in a field theory language, right? We have an electron and a positron. So these are charged particles, but they both have their fields that they're really vibrations in. So there are these fields filling all of space, the electron field, the positron field. In modern quantum field theory, you actually join them together. You would join particles and antiparticles together into a single mathematical structure, but that's okay. Doesn't matter. Conceptually, there's an electron field and a positron field. And it turns out that these fields are complex fields. What does that mean? A field is just at every point in space, there's a number, a value for the field, or maybe some slightly more sophisticated geometric quantity. So like the electric field is a little vector at every point in space. A vector has both a magnitude and a direction. The electron-positron fields, and I'm also ignoring spin because there's too many things you got to ignore, but that's okay. At every point in space, there's a complex number. That's what it means to say they're complex fields. So complex number is just not a complicated number, it's just a real number plus an imaginary number. A plus IB, okay, where A is a real number, B is another real number, I is the square root of minus 1, the imaginary unit. So the numerical value of the electron field at any one point in space is a complex number, A plus IB, for some definite numbers A and B. Now, one of the things about this complex number, set of complex numbers is you can think of it as a plane, right? We talk about the complex plane. It's almost like it is in fact a two-dimensional vector space. You can think about one axis being the real part of the number, which we label A, and then the perpendicular axis is the imaginary part of that complex number, which we label B. So you have A plus IB, A is going horizontally, B is going vertically. The actual complex number, A plus IB, is some dot on that plane, and you can imagine drawing a line from the origin to the dot, which looks like a little vector. The reason why I'm saying all that is because if you've played around with vectors ever in your life, you might be familiar with the idea that very often the vector itself has some intrinsic meaning, but the particular coordinates in which we express the vector don't have any real physical meaning. So if I set up a coordinate system here in my room, x, y, and z, so maybe x is going, I'm pointing in a direction right now, you can't see me, but that's x, here's y, and z is vertical, okay? Then I can tell you what the components are of, let's say, the electric field at one point in space, because we'll have a component in the x direction, a component in the y direction, a component in the z direction. But physically, the electric field doesn't know what components I've set up. It doesn't care. The physics of the electric field are independent of the axes I use to define the components of the field. It's the vector that matters, not the axes with which I define it. So in some cases, that will also be true for complex numbers. You have A plus IB, but you could rotate those two axes, the real axis, what you're calling the real axis and the imaginary axis, you could just rotate them, and the physical essence of the thing you're describing is unaffected, just like the physical essence of the electric field is unaffected by me changing coordinates here in the room, okay? So if you have a field that has that kind of invariance, that it is a complex number, but it doesn't matter how we choose to define what is the real part and what is the imaginary part, as long as we do so consistently, then you have a symmetry. That kind of invariance is called a symmetry, and that is the kind of thing that pervades all of modern physics. And that might make sense. See, that kind of makes sense. It doesn't really matter which is the real part, which is the imaginary part. That's a human convention, okay, blah, blah, blah. And that's fine. But what's going on in modern particle physics is a little more subtle than that. It says that I'm picking at a point right in front of my nose right now. Again, you can't see it, but imagine a point in space. It says at that point in space, there's a symmetry that says I can separately rotate the real imaginary part of the electric field. No physical difference is being made. But I can pick a different point, any different point I want. Fix a point in your brain. Look at that point. And I can, again, rotate the real imaginary part of the electric field, the electron field. I can rotate the A and B components together in some different coordinate system, some different basis for the vector space. And the magical thing, the important thing, is I can do that separately at each point. At every point in space, I can separately rotate the real part and the imaginary part of the electron field, and this turns out to be a symmetry of the theory, okay? That's a gauge invariance. It's the idea that you can separately rotate the bases of your vector space, whatever that happens to be, at every point in space, and the theory as a whole is physically unaffected by it. Another famous vivid example are the quarks. You may have heard the quarks come in colors. They're either red, green, or blue. Not real colors, just whimsical names the particle physicists have given to them. It's not really even true that quarks are red, green, or blue. What really is true is that there is a three-dimensional vector space. And every individual quark field has a certain direction in that vector space. And the axes of the vector space are the red direction, the blue direction, and the green direction. And guess what? Nobody cares. There's no physical relevance to how you orient your red, green, and blue axes at every point in space. And you can rotate them independently all throughout space-time. That is a different kind of gauge invariance. So for the electron, you were just taking one direction of rotation, and that is called U1. For the quarks, you have three different axes, and the rotations you do are called SU3. That 1 and that 3 are literally the number of dimensions you're rotating into each other. In a weird counting system, because the complex plane counts as one complex number. So you're really rotating one number into itself. That's a little bit of math you don't need to worry about right now. The point is, even though you might say very reasonably that I don't care how I set up A plus IB at any one point or red, green, and blue at any one point, I do care physically how to relate them at different points in space. How do I know if the electron field at this point and the electron field at that point are pointing in the same direction? If I change my axes, A plus IB, right, then I need to compare them somehow. So what I really need to do is a way to take the electron field at one point in space and walk it over to the other point so I can compare them. You can't just compare them at different points. They're not next to each other. You can't subtract them from each other. They need to be next door. So you move the field at one point to the field at another point. How do you do that? The answer, which is the kind of thing that makes graduate students in physics just their eyes light up with sparkles when they finally realize this, because it's very, very beautiful and very, very compelling. The answer is you need another field. You need a different field in addition to the electron field itself. You need a field that tells you how to move the value of the electron field at one point to another point in space, or the three dimensions of the quark color space to another point in space, or in real space-time. You have curvature, right? How can you describe the value of a vector at one point in space compared to the value at another point? You need to carry it, and you need a field to tell you how to carry it. And these fields are called connection fields for obvious reasons. They help you connect one point to another. They're also called gauge fields. And in the case of electromagnetism, this gauge field is literally the electromagnetic field. What you think of as the electric field and the magnetic field are the amount of rate of change, either in space or in time, of the underlying gauge field. In the case of quantum chromodynamics and SU3, they're the gluon fields. In the case of curved spacetime, it is the gravitational field. There's a more subtle connection there because there's a metric and a connection, but it's another story that for another time. The point is that over and over again, what you see once you have a field theory is the possibility of these gauge symmetries, which require a gauge field to make mathematical sense of. And that field has a dynamics of its own. You don't need an electron field to run around to have an electric field or a magnetic field. Likewise, you don't need a gluon field around to have, you don't need a quark field around to have a gluon field. They have a life of their own with their separate dynamics. Maxwell, when he wrote down Maxwell's equations in the mid-19th century, some people today will say, Maxwell, he had the electric field, he had the magnetic field. He didn't know that there was gauge invariance, that there was an electromagnetic potential field from which you could make that. He did. He totally knew that. If you look at Maxwell's books, he absolutely knew that you could construct what we now call the gauge field for electromagnetism, and from them, by taking derivatives of them, make the electric field and the magnetic field. What he didn't have was the whole symmetry group idea. He didn't have the idea that the matter fields, like the electron, would also be fields with their own ways of changing under these gauge symmetries. But he knew about gauge invariance. And classically, Maxwell's electrodynamics is like the paradigm of a wonderful classical field theory, and it was soon developed into the paradigm of a wonderful quantum field theory. Quantum electrodynamics, QED, was the first quantum field theory to be really, really studied in detail and phenomenologically successful. So people knew about gauge invariance, and they knew that it was wonderful, and it was a very, very natural thing to say, well, maybe the forces that we don't understand. So thinking now of the 1950s, okay, we've done pretty well with QED electromagnetism, but like I said, we have these things called nuclei, where the protons and neutrons are hanging out together, and there must be a force holding them together because the electromagnetic force all by itself would push protons apart. It would not hold them together. So we need a new force. Maybe, people said, it's a force that is kind of like electromagnetism, but more complicated. And the first people to say that this were Yang and Mills, and so they invented Yang-Mills theories. But there's instantly a problem with Yang-Mills theories. So Yang-Mills theories are theories with connections, with gauge invariance, but in a more complicated way. The technical terms are non-abelian. The symmetry group does not commute with itself. It matters which symmetry transformation you do first and then second versus second and first. Who cares? We don't care about that. That's not our goal right now. The point is, there was a generalization of the idea of gauge invariance that seemed maybe promising, but had a huge problem right from the bat, namely that the photon, the particle that carries the electromagnetic force, the particle excitation of the underlying gauge field in electromagnetism, is massless. It moves at the speed of light. It zooms across space very easily, very readily, okay? It gives rise to a long-range force. Coulomb's law is just like Newton's law of gravitation. It's an inverse square law. It's very easy to extend electromagnetic force across great distances in space. This turns out not to be a weird, quirky thing. This turns out to be, apparently, a necessary feature of gauge theories. The field that is the connection that you get when you have a gauge theory seems from the math to be necessarily massless. And massless particles are easy to make and easy to see. But in the 1950s, they didn't see any massless particles popping out of the nucleus. So what's going on with that? Okay, you might think I've been going on too long. I have, but I'm going to make it a little bit shorter now. So I'm going to really sort of shortcut how to get out of this problem. But I really want to highlight the problem of the massless gauge bosons because it really bugged people for decades. And there's two forces that you might worry about, the weak nuclear force and the strong nuclear force. And because nature wants to make life as hard as possible for graduate students in physics, it solves the problem in two totally different ways for the weak nuclear force and the strong nuclear force. For the strong nuclear force, it solves the problem because the gluons, which are the gauge bosons of the strong force, interact with each other. And they interact with each other very strongly, so strongly that even though they are massless and they do want to move at the speed of light, in fact, they are confined inside strongly interacting particles like protons and neutrons and mesons and so forth. So that's a very interesting piece of quantum field theory. Won the Nobel Prize for David Politzer and David Gross and Frank Wilczek under the name of asymptotic freedom. But the basic lesson is the quarks are the gluons rather are massless, but you can't see them because they're confined inside collections of strongly interacting particles. In the weak interactions, the answer is the Higgs mechanism. This is why the Higgs boson was such a big deal. The first person to actually point out what was going on was Philip Anderson, who was a condensed matter physicist who passed away. He won the Nobel Prize separately for his work in condensed matter physics. But the idea is spontaneous symmetry breaking. If you have another field that is invariant under this gauge invariance that you've invented, but it gets a non-zero value in empty space, a vacuum expectation value, that will give you the impression that apparently the symmetry is being broken, and that will allow the bosons, the gauge bosons that were supposed to be massless, to now be massive, which we know the W and Z bosons actually are. This is what actually happens. But the first investigations of this spontaneous symmetry breaking by people like Nambu and Goldstone and others saw that even though you could give a mass to, they didn't say that. They were worried, let me get it exactly right, they were worried about global symmetries, not gauge symmetries, so there's no gauge bosons at all. You could only do that rotation uniformly throughout space when you rotate the different axes together, okay? In these global symmetries, there's a theorem, Goldstone's theorem, that says you will always get a different kind of massless boson, basically because it causes zero energy to move around this field that you have used to get the non-zero value in empty space. And again, you don't see any of these massless bosons, so people were kind of rumbling like, oh, it's a mathematically cute idea, doesn't seem to work. It was Anderson who pointed out that the two problems cancel each other out. That if you have spontaneous symmetry breaking with a gauge symmetry rather than a global symmetry, then the would-be Goldstone bosons, the particles that were supposed to be new massless bosons when you broke the symmetry, get eaten by the gauge bosons. And the gauge bosons, by doing that, get heavy. So rather than getting two kinds of massless bosons, massless gauge bosons carrying the force, and the massless Goldstone bosons from breaking the symmetry, you get one kind of massive bosons. And that's exactly the scheme that was used in what we now call the electroweak theory. So Higgs, and even before Higgs, Brown and Anglaire, and just after Higgs, Goralnik, Hagen, and Gibble, they followed Anderson, and they really did particle physics of it. Anderson was still thinking like an matter person, but Anderson was trying to point out to his particle physics quantum field theory friends that they could escape this puzzle. If you spontaneously broke a gauge symmetry, there's no massless particles lying around. Interesting sidelight. Look, it's my podcast. I can ramble as long as I want. Interesting sidelight about this. We're going to get to the crisis of physics soon. Don't worry. Why didn't Philip Anderson, who's a very smart guy, push his idea harder? In history of physics, you get credit for coming up with ideas, but you also get credit for sort of believing your own ideas and pushing them. And Anderson didn't really quite follow through on his idea that spontaneous breaking of gauge symmetries gives you no massless bosons at all. And the answer, as far as I can tell, is the cosmological constant problem. This is worth talking about because it's going to come up more than once. The cosmological constant problem is the idea that ever since Einstein says that general relativity is a theory of curved spacetime, it was open to the possibility that there is a vacuum energy, that there's an energy density in empty space itself. And this is mathematically identical to Einstein's idea of the cosmological constant. They're the same thing. There's no difference. There's not like this is the cosmological constant, that's the vacuum energy. They're the same thing. Okay, just different languages used to describe the same idea. The difference is that long after Einstein, by the 50s and 60s, people realized there could be different contributions to the cosmological constant. So in fact, Feynman, I think I understand this correctly, but it's not a common fact, so maybe I'm hallucinating a little bit. One of Feynman's motivations for inventing Feynman diagrams was to get rid of quantum field theory. Back in the 50s, you could be ambitious like that. Right now, quantum field theory works too well. It's a harder ambition to have. But in the 1950s, you could have said, well, maybe I can get all the benefit of quantum field theory without all the downsides like the infinities, right? And one of the things that he knew was a problem, Feynman, was that if you have a field that fills all of empty space, even if there's no particles, right, even if it's in its lowest energy state in the vacuum state, it can still have energy. It can have what we call the 0-point energy. And naively, you calculate 0-point energy, and it's hugely big. In fact, it's infinitely big, but Feynman wasn't surprised by that. Lots of things in quantum field theory are infinite. So that's what we call the cosmological constant problem. Naively, in quantum field theory, there's a quantum contribution to the energy of the vacuum, which is very, very big, maybe infinitely big, depending on your attitude towards high momentum, high energy modes of the quantum fields. And Feynman thought that maybe he could invent a theory that was a truly particle theory, right? It was really a theory of individual photons and electrons and so forth that would replace quantum field theory. It didn't work. Nowadays, we know that what Feynman diagrams really are a useful calculational tool for talking about quantum field theory, not a replacement of quantum field theory. So Feynman was motivated by the cosmological constant problem, but it ended up not being very relevant to what he actually did. Same thing is true for Phil Anderson and spontaneous symmetry breaking. Anderson realized that if there was a field filling all of space that was breaking these gauge symmetries, it would carry energy, that field, and he estimated the size, and it was big, much bigger than was possibly allowed by cosmological observations. So Anderson said, yeah, it's probably not on the right track. I will spend my time doing other things. Since then, we have learned to mostly ignore this problem. Now, we don't ignore the cosmological constant problem. We know it's a problem, but we state that it's a problem. We state it's important to think about. We try to think about it, except that when we're doing quantum field theory, we just say, yeah, for some reason, the vacuum energy is very, very small. We don't know why, but it is. That's the best we can do right now for the cosmological constant problem. And again, it turns out that in 1998, we discovered that the universe is accelerating. We had Adam Rees on the podcast. He was one of the discoverers of that. And that seems to be best fit by the idea that there is a tiny amount of cosmological constant out there, a tiny amount of energy in the vacuum, much, much smaller than you would estimate, either from the 0-point energy of the quantum fields or the extra energy you get from the Higgs field. So there's still a cosmological constant problem, but it's not why is the cosmological constant zero, it's why is it a small, not quite zero number. That's the current version of the cosmological constant problem. Okay, so then there's a whole bunch of more details about parity violation and non-perturbative phenomena and confinement and gluons and generations and families and all these things that ultimately triumph in the 1970s in the standard model of particle physics. And as you know, sometimes I like to talk about the core theory. That was a name given by Frank Wilczek. What's the difference between the core theory and the standard model? The standard model is everything other than gravity, because we say, oh yeah, gravity does not have a full quantum field theory description or quantum description yet, so it doesn't count. Which is true, that we don't have a full quantum theory of gravity yet. But remember what I just told you a few minutes ago about effective field theories, right? If you confine your attention not to every possible situation, but to certain situations where the fields are relatively low energy and long wavelength, then you can invent an effective field theory that is true below some ultraviolet cutoff. So it turns out you can 100% do that for gravity. No problem whatsoever in including gravity in your effective low energy theory below the UV cutoff that you personally favor. And that's what the core theory is. The core theory is the effective field theory that includes both the standard model and the weak field limit of general relativity. So it doesn't include the Big Bang or black holes. That's okay. We don't have the Big Bang or any black holes here in the solar system as far as we know. So our lives are very well described by the core theory. Again, good news, bad news situation. An amazing triumph. The core theory, the standard model in the 1970s, made predictions, right? The W and Z bosons were predicted and then observed. The generation structures of the quarks and the leptons. So when we discovered the bottom quark, we knew there had to be a top quark. We discovered that. We predicted the Higgs boson. It took a long time to discover that. Comes around in 2012. That's good news. There's nothing but good news. Many Nobel Prizes were given out for all the work that went into constructing this model. The bad news is, several decades later, that model continues to fit the data. There were two tiny updates, right, around the turn of the 21st century. One is neutrinos have mass. That was not part of the original standard model, but everyone knew it was not hard to put into the standard model. Again, it's sort of this weak understanding situation where we don't know exactly what the mechanism is responsible for neutrino masses, but it's easy enough to include them. So it's a modification of the standard model, but not an overthrowing of it in any sense. The other one was, of course, the discovery in 1998 of the acceleration of the universe. Again, put one number.
Okay. hmm We'll come back to this at a later time. Um, Let me see who is on the servers. This server is useless. I see there's some people can't talk to them. Hello.
Hello, Mr. Slave.
Hi.
How you guys doing? You know how you going,
I'm
mate?
Vanu. God, fucking been ages since I've spoken to you, assuming that it's the same guy I remember with that profile pic from ages ago.
Oh no, just from the other day.
I don't remember.
So, do you want to have a chat, debate?
We can have a casual conversation.
Let's do it.
People want to talk?
So, you believe that we spin around the sun? Is that correct?
Believe mechanics more complicated than just that, but yes.
Wait.
Just
Before.
generally speak, Mr. Slave, go ahead.
Yeah.
brother.
Yeah.
I'll
I'm
listen.
sorry. Does any of you know anything about entanglement? Quantum entanglement?
No, it's a bit wibbly wobbly, timey wimey.
Huh?
I know it's a bit wibbly wobbly, a bit timey
I
wimey.
do understand it completely, and that's part of the reason why I'm a flat earther, due to quantum mechanics and entanglement. And I know the conclusion to string theory, which is quantum mechanics and traditional physics, finding the
Mm,
combination between them. And the conclusion is the fact that there is a creator to this world, Jesus Christ. So the
okay, I'm
conclusion
going to
to
completely
string theory
disengage
is
with you
Jesus.
because
Okay, fine.
saying
Look,
there is a
we don't
creator
have
doesn't
to
matter to
get
me.
involved with this, but that's all I had to say. All
Hmm.
right, that's my answer to Mr. Slave about entanglement.
Well, let's talk. I mean, um, would you? Okay, let me ask you a question. So, what do you know about experiments, actual experiments around entanglement? Like, what experiments are you familiar with?
Who's that?
Magnetism.
Yeah.
So, especially incoherent magnetism. So, we're looking at negative and positive polar charges, which is we're looking at double toroidal fields. So, we're looking at singularities here,
Wait,
right?
wait,
And this is what causes entanglement. It's a duality of a it's
wait,
an
wait.
expression of a duality.
Hold on, hold on. I'm asking, could you tell me about a specific experiment that has to do with entanglement?
Um, yeah, that's a good. I just have to, not an experiment, but the expression of magnetism as a whole, definitely. You know what I mean by this. I can send you images if you're a visual learner.
No, no. I want to discuss a specific experiment. Like, for
So,
example,
experiment is using a magnet and putting iron dust around it, and you get the expression of a toroidal field, which is something which is eternal and is the formation of what gives way to what we consider entanglement, right? Which
what?
is polar opposites
No, no,
being one and the same, which is
no,
quantum entanglement.
no,
That's
no, no,
exactly what it is.
no,
So they're one and the same, but they appear to be opposite. That's
no,
what entanglement is.
no, no, no. Quantum entanglement has to
Go
do
ahead.
with, hold on. Quantum entanglement has to do with quantum particles. So you need to discuss, you need to pick a
That's what I'm talking about.
what part, what
So you,
quantum,
so what I'm saying to you is this
what
experiment
quantum, wait, what
is an
quantum,
expression of
wait,
the quantum world.
wait, what quantum particle are you discussing right now?
I'm talking about the expression of the concept that you're talking about.
You tell me,
It's a
look,
manifestation of what I just showed you.
look. So I want to be specific about this. I don't want to have,
You be specific with an example, my friend.
yeah. I
Go
want,
ahead.
I mean,
Go ahead.
I'm asking you, are you familiar with a specific,
No, no, no. So I am. So the idea is you'll have a negative charge somewhere or something
but there's no, but there's no
polar
quantum
opposite to something else anywhere else in the
in
universe,
your
right? But they'll be
diagram, in,
completely
but
connected,
in your
completely
figure,
defying the law of physics.
in your figure,
That's what quantum entanglement.
in your
Go ahead.
figure, in your figure, there's no reference to any quantum object.
Of course there is. It's the manifestation of the power or the idea that's eternal. And look, yin and yang, it's so plain and simple. Yin and yang is what the quantum entanglement is,
No,
essentially.
no.
So the geniuses love simplicity
Wait,
and
Can
midwits
I ask you,
like complexity. Go ahead.
can I ask you a personal question?
Yes.
Have
Yes, you
have
can,
you,
brother.
do you feel like you're a normal person in general?
Well, I have a job and I work 5 days a week, and it's Friday, so I would consider that a normal person. Thank you.
Mm-hmm.
I'm a gardener,
Mm-hmm.
and I work on millionaires' properties, and I'll get them completely. You won't see one blade of grass sticking up on a massive property. Okay,
Mm-hmm.
I
Mm-hmm.
spend 8 hours a day on the ride-on mower, snipping every single blade of grass. And you're going to ask me, am I a normal person? What did you do today, Mr. Slave? So I know the earth. I'm a gardener. Okay.
Mm-hmm. Mm-hmm.
We are discussing what the earth is.
I don't want to offend you. I'm not here to offend you. I'm curious.
You didn't defend me, but it was a really stupid question with a stupid premise. Do you not
Well,
agree?
yeah, I agree, but I'm
There you
curious.
go. Well, let's move ahead. Were you curious? I know you're. You curious, George. Are you a globe earther by any chance?
No, I hate.
I know
Yeah,
the majority of you guys here are globe earthers,
no, no.
so
I'm
this
I'm
is
a
your take.
mainstream. I'm a main. I believe in mainstream physics, but
Oh, okay.
globe earthers, whatever, run away from me. They're
So you're
afraid.
a flat earther.
No, uh, no. I whatever I like. I don't believe in exactly
Well,
what
I'm a flat earther.
I understand that. Anyway, but if you ever want to see a globe earther run
So,
away,
do you want me to explain to you what a flat earther is? It means that
no,
we perceive
no,
the.
no,
I'll
no,
just say real quickly,
no, no, no,
we
no,
perceive
no,
a
no, no,
horizontal.
no. I'm not.
Fine, go ahead.
I'm sorry. I'm
You don't want to hear
honestly.
it.
Yeah, yeah. I've heard enough
You've
of.
had enough of it.
Yeah, that's like
That's
telling
fine,
me
brother.
about Jesus. I don't want to hear about Jesus. I heard enough.
Oh yeah. Well, he's my savior. Amen.
I don't want to hear. I'm sorry. I'm sorry. Like,
Amen, Mr. Slave. Go ahead.
look, if you were a hot chick and you wanted to tell me about Jesus, that's fine. But if you're not a hot chick, I don't
What
care
on
about
earth?
Jesus.
What on earth are you talking about, brother?
It's to me, Jesus is utter nonsense. It's complete
Yeah, that's
nonsense.
fine. You're a secular human being. Okay, there's plenty of people like you.
No,
You're not
no, I'm
special.
extremely
So
spirit.
you are asking part of you're spiritual.
I'm extremely spiritual. The fact that you choose to live a life of
Okay.
lies with your fictional
Oh, that's
Jesus,
fine.
that doesn't make
Well,
you
I found him. Listen,
well.
I found him 2 years ago, and he concluded my reality. Can I just say one thing?
No,
So
let's
you
forget
can't
about. I don't want to talk.
deny
I don't want to talk.
context.
I no no. I don't
I'll
want.
just say one thing.
No no no. Please
It
no.
is related. I'll give you. It's literally one word.
Look, I understand.
Context.
I understand. I
So
understand.
Jesus Christ is
I understand.
contextually
I
relevant
understand. I
to
understand.
our
He
world
was a communist.
spiritually.
He was a communist, and I hate
What
communists.
on
Yes,
earth?
yes,
He was not
yes.
a
He was
communist.
a communist. He was against
Blasphemy.
money. He hated money. I love money. So,
Blasphemy.
okay, look, I hate Jesus. He was an idiot. I love bankers. Bankers are the best people in the universe.
Jew.
So, what? What did you say?
Are you Jewish?
Okay.
Did you hear what you just said? You're
I
trolling, bro.
No,
Bro,
I'm
you're
not.
trolling.
No,
You're
I
just
love.
baiting me. You're trying to get me muted.
No, no. So just stop with your nonsense. I love bankers. I love banking. I love
But
finance. I
you're
love
trolling.
investment. What? But you don't. Okay, you don't like money.
I've
You
never heard
don't
a
like.
person
Oh,
ever,
you don't like
dude.
money. You're a liar.
Well,
You
you
live
just
a life of
described to me.
lies. You live.
You think dude? I'll tell you one thing. I was in Sydney the other week, and when I was leaving on the train station, I looked at my wallet, and there was a chick, a what do you call them, hobo, just a chick lying on the side of the train station with a coin purse out, and I just whipped out $20 and gave it to her, and she probably spent it on drugs. There was another time
Never
in a
mind.
local area
Let's
of
continue. Okay,
near
so
Centennial Park. Hey, I'll just say one thing. I was walking
no,
across the
no.
road and
Come
there
on,
was this
then
guy who was a
I don't
heroin
want to.
addict. I spoke to him and I
It
was like, the
doesn't.
thing is, I spoke to him, said, yeah, I'm
I
trying to
gotta
get better. I'm
go.
trying to have a good
Wait.
time. Yeah,
I'm
yeah, yeah.
gonna go. Look, I don't want. Either we talk about actual physics or I'm leaving. I don't want to waste.
Talk about physics. You got me carried away, man. You got me on
Let's
a
go.
really good ride.
Okay. So
Sorry about that, brother.
yeah, it's
That's
okay.
fine.
Let's talk about physics. So entanglement. You know nothing about
Yeah, yeah.
entanglement?
No, I do know about these subjects. Okay,
No, you
this is
don't.
what you misunderstand. You think I
Okay,
don't
I
know.
gotta
In
go.
fact, I
Wait,
do.
you know, you know. Do you want to talk? You know?
I'm open to having a discussion.
Okay.
Go ahead, talk to him then.
Yeah.
Fine.
Thank you,
If
Vano.
you
I'm
don't want to have a
sorry.
discussion, that's fine.
The problem, Vanny, is Slave is trying to express what he wants to engage about, and you're not engaging about
Talk
that sort of
about
thing.
what. Go ahead, brother.
It's okay. It's
Because
okay.
I try to
Vano,
talk about what I
Vano.
know about
It's
it,
fine. It's fine.
but you have your own idea in
It's
your head.
fine.
So go express
It's
it.
fine. It's fine. Let's continue. So, you know, what do you know anything about quantum entanglement? You know, you there? You know, are you there?
I am
Do you know anything about quantum entanglement?
not overly no.
Do you know anything about it? Have you ever heard of it?
I know ballpark about it, mostly from the video game Mass Effect, where they have the idea of a quantum entanglement communicator so that you can send bits of information across an infinite distance and have a conversation, essentially, which is a really cool concept. That would be so cool. Of course, it would be limited to point A to point B and wouldn't be good for networking lots of people together. But it's a cool idea.
hmm So how does it work? How does quantum entanglement work in the game?
It's not a core mechanic, it's just using an explanation, but the idea is that they have two, I assume, molecules, atoms, whatever, in an entangled state, and when you shift one, it shifts the other. So you can send essentially ones and zeros by shifting one, and you get the inverse out of the other one. So therefore, you can send a form of communication, even a video file. You could send that way.
I don't think you can actually send information this way. I don't think you have control over.
No, but that's the explanation in the video game of how they do it.
Oh, I see.
Yeah.
Okay, yeah.
So
Okay,
with a
so,
suspension of disbelief, but yeah.
okay,
That's the
so
idea.
I don't see how there's an issue in sending information. Let's show that it's possible to send information instantaneously across the universe. Let's demonstrate it. So I and you were across the universe and we share an entangled particle. Now you measure it up and down in a vertical direction and you get up. Instantaneously, you know I got down.
Yeah, essentially.
When I measure it, I get, of course, down because that's how it works. So I know you got up. All right, we know something about each other. We're sharing information. I know immediately. I know your bit. The question is, can we put this to any good use? That's a good question. I don't know, but okay. Let's. So, would you say this is magical? Would you say this violates the speed of light, special relativity, the fact that we cannot send information faster than light?
Mm, nothing to do with not being able to send information faster than light, just that something can't. Oh, wait, gravity is thought to not move faster than light.
Nothing moves fast. Nothing moves faster than light, as far as we know.
Nothing moves faster than light, but is entanglement moving in that principle? I don't know. I don't know enough about it to really say. It's an interesting question. Like, would it be limited to the speed of light? Because, even theoretically, gravity, if the sun suddenly disappeared, the gravity wouldn't disappear for 8 minutes, sort of thing. It's an interesting question.
So there's two ways to explain entanglement. There's two ways to explain this experiment that you described. So yeah, I don't see how it's possible to share information. This should give you a hint that no information is being shared. If you cannot send me information through this process, that this should give you a hint that you're not sending me information. Nothing is moving from you to me or from me to you. This should give you a hint. But never mind. That's just
Well, there's.
go ahead.
Sorry.
Yeah, no, go ahead.
So I was just gonna say that I've never heard anything beyond you checked and let's say the spin is left on your end, therefore it's right on my end. But no one, well, not no one, but I've never heard of the explanation that's further than this. So can you change the spin on your end so it changes on my end, or would it also change the spin or state or whatever when I check again? Because the fact of checking determines the state, right? So is it not possible to send information because the fact of checking determines the property, um, and therefore it potentially changes it randomly, or can we manipulate the state of the particle on one end and see the change on the other end?
So I was listening to Sabine Rosenfelder. I don't know if you know her. The other
Yeah.
day, and in a video, she says that entanglement, there's no spooky action, and it's basically anyway. She doesn't believe. She takes the Einstein's position, and that it's explainable without any magic.
Okay, well, Mr. Safe, do you have any example of quantum entanglement that you have in mind, or
Sure,
you've just
sure,
heard of the concept?
sure. In a second, let me just answer Darnock. So anyway, in that video, she says explicitly the following. She says, they'd never bother to tell you that if you change the spin on one of the particles, it has no influence on the other. Which is,
Ooh.
yeah, they don't, they never meant, this is, she literally says that. She also says, why do physicists keep saying that there's something magical about entanglement? Maybe it's because people want to believe in magic. She literally says that. I mean, she honestly, I mean, if you want to hear someone who hates the mainstream quantum entanglement nonsense, that's Zabine. I mean, she really hates it. Not as much as I hate it, but she hates it, and she feels that she has disproved it. But I think I can also disprove it anyway. It's to me it's nonsense
What
anyway.
makes you hate it?
It's nonsense. It's like Jesus. Don't you love it when people start telling you how Jesus can is your
It's
Lord and
your loss,
Savior?
brother.
Yeah,
Hey, it's your loss.
I hate
Keep
Jesus.
it to
Just I
yourself,
hate
mate.
Jesus. Just I actually
I know you do.
I love Jesus compared to entanglement. Let's just say that, and I hate Jesus. So you know anyway. Basically,
That's fine, brother. Do your
entanglement.
own thing.
Wait, Vanu. Entanglement to me is comparable to any other cult. It's utter nonsense. It's cultish. Nothing to do with reality. Nothing to do with science. Just nonsense. And the fact that the
So
main.
you completely disregard the fact that we have emotional bodies, don't we? So imagine if I just flipped on you
Wait,
and started
Vanu.
calling you names and started calling you words, okay? You would have an emotional reaction, okay? Jesus Christ and God and the soul are all relevant to the mind
Not
and
to
how
me.
your emotional
I
body
told you
reacts,
I don't like Jesus. I don't like him.
okay?
I don't like
No,
communists.
no,
I don't like
you
people
just
that I
misunderstood.
don't like people that hate bankers.
Go ahead.
If you spread
I
hatred
don't
of
I think
bankers,
I don't think bankers should exist.
fine. Then me and you see with the world in opposite
We
ways.
should live in a society
You
where we
you
should
you
trade things.
you are
So
anti-civil.
say I earned something. I say I earned something and I traded you. So there was no currency involved. There was
Yeah,
only effort.
which is
Between effort.
right. You work from morning until night to
No,
make
I work
money.
with the land.
Okay,
So
okay, let's
my
not waste
people
time.
work
I don't
with
want
the
to waste
land.
time. I don't want to waste time. We can have, if you, Vanu, if you're open-minded to talk about banking and finance and investment, you're not, then fine.
So you're talking about infiltrating societies
Okay,
and
Vanu,
using them.
let's continue with entanglement. Anyway, so entanglement
Go ahead.
entanglement
Continue.
entanglement is cultish. Anyway, let's disprove
Well,
entanglement.
hold on. Question.
Yeah.
What do you mean by cultish?
it it's like there's no reason. Like if you have a cult of people that believe in Jesus, and as much as you explain to them that it makes no sense, you cannot you cannot
You're not gonna win this
yeah,
argument,
you
dude.
you
Just move
simply
on.
you use logic and facts and reason to try and
Just
uproot.
move on.
Vanu, stop. You try to uproot Jesus from
You
the.
stop.
Vanu, stop. You try to.
You're blaspheming it as if it's a
I'm
normal
sorry. I'm sorry.
conversation.
I'm sorry. Okay,
You know, you.
Fine,
Have
fine,
you, Mr.
fine,
Slave, have you ever
fine.
heard of something called respect?
Vanu, I used to belong.
Respect? Question mark?
I used to be
You think you
much.
can just shit all over
I'm
Christians?
sorry,
Who do
Vanu.
you think you are?
I used to be much worse than you, so I'm criticizing
Oh,
myself.
get a grip. Get
Anyway,
a load of this guy.
it doesn't matter. I'll use a
You're
different.
so rude, dude. Just
I'm
move the
sorry.
conversation forward.
Fine, fine. Okay, let's talk about, I guess, Scientology. I don't know. Pick your favorite cult, and if you've ever, like a flat earther, pick your favorite cult, and you see that you cannot prove to them that they're wrong. You simply cannot.
Okay, so you believe that the Earth is spinning around the sun?
That's not the point right now, Van. I don't want to get into
Okay.
it. I don't want to wait. I don't waste my
Well, it
time.
obviously isn't happening. That's the
Vanu,
point.
Vanu. Okay, so now you see what I'm talking about. Like flat earthers to
Don't
me.
talk about anything.
Wait, Vanu, stop. Flat earthers to me are either they're mentally insane, which I think a lot of them are legitimate schizophrenic, or
Dude, you're brilliant. You're absolutely
Vanu,
brilliant.
Vanu. I'm sorry. It's look. I'm saying some of them,
You should be sorry.
not. I didn't. I'm not saying you are. I'm saying some of them are legit schizos, legit mentally insane,
Well, you can
and
say this about both sides.
yeah, yeah, sure. Look, but the point is, he asked me, what do I consider a cult? A cult is when I am unable to convince someone of what is to me simple and straightforward and obvious, and I just cannot. We have a disagreement, and there's nothing I can do. So I have to say, okay, that is a cult. I mean, if it's part,
I
if it,
wouldn't say unable. I would say it is a group of people that are unwilling to even consider changing their view
fine,
when they are utterly closed to the concept of being
yeah,
shown something,
yeah,
shown it differently.
yeah,
That's a cult.
yeah.
Well, in this regard, you need a very convincing alternative.
Fine,
How about that?
Vanu, hold on.
That misses the
point.
point of the definition. We're not saying that we don't have something convincing. We're saying that nothing would convince you. The hand of God
Dude.
could literally come down and say it's a ball, and you may still have hesitation.
Wait,
Like,
hold on.
it's that
Vin-
level.
I
One
don't want
second.
to. I don't want to go into a discussion with Vanu. I respect Vanu. Vanu is a nice guy, but you
You
asked
don't
me.
really
Win.
do. Hey, Mr. Slave, you don't get to do that. All right, it's a public server. You don't own this. So, as he just said before, a bit of respect. And I'm backing up Svenu. He has as much right, if not more, to be here because he's new. So show
Yeah.
respect, Mr. Slave, and you'll
Yeah,
get some
cheers,
back.
mate.
If
I-
he
Thank
wants
you.
to start a conversation in a certain direction, he's allowed to in this forum.
Yeah, I'm just.
Yeah.
Yeah, I just don't want
Wouldn't-
to. I just don't want to have a discussion. Yeah, I mean, Vanu wants to talk about maybe flat Earth, and that's not. I'm not interested in that. I mean,
Cool.
Go ahead,
But if
mate.
he wants to have that discussion with me,
yeah,
you don't get to block that.
I don't. Of course not.
No.
No, I didn't say.
So that's the point Boomer's making. When he starts talking about it and you go, I don't want to talk about that. Not the point. If he wants to have that discussion with me, he can have that discussion with me.
Of course.
If he wants to have that discussion with you and you don't want to, that's fine.
Right. Right. So, it's up to you. I mean, if you want to talk about entanglement with me or flat earth with Vanu, just let me know.
My knowledge of entanglement is extremely limited. I can't really take that conversation really any further than what I know from a video game.
Well, there's not much to know. There's really not much to know. I mean, you know basically everything. There's not much more
Oh,
to
cool,
know. I don't think.
I guess we're done then. There's not much more to know, then it's over.
All right. Over. Goodbye. Have a great rest of your life. Then it's over. Okay. Goodbye. Have a great rest of your. Oh, I cannot create a room without. They change. Wait, I think in PNR it is possible to create my own private room, but there's no one here. Private chats. This is, yeah, this is a complete waste of time. This is join to create. Yeah, this works. Mm-hmm. Mm-hmm. Where is that? That's good, but I see. But in politics, I cannot create my own room. That's terrible. Hmm. Chill chats. Billy's gym. Hello.
السلام عليكم ورحمة الله تعالى وبركاته.
Alaikum assalam. Do you guys want to talk about entanglement? Do you know anything about entanglement?
What is entanglement?
Quantum entanglement. It's like quantum physics. Do you know anything about quantum physics?
I mean, I know some, but I've studied that in Arabic, so.
Okay, entanglement is like when you have when a particle decays into two daughter particles and the
Oh,
parent,
yeah.
so the parent has zero spin and the two daughter particles have, somebody's hot micing. Arthur, you're hot micing. Arthur? Okay. So the two daughter particles have opposite spins, and then you measure them both simultaneously, and you always get opposite measurements.
وعليكم السلام ورحمة الله تعالى وبركاته. I see.
So, are you familiar with that?
Yeah, familiar with it, like more in Arabic.
Yeah, we're watching something right now, bro. Like, we're watching something.
What?
We're watching something, Mr. Slave.
Hi.
I said we're watching something.
Oh, okay. I'll go. Thank you. Hello. Mitch. Mitch, are you there? Mitch.
Mr. Slave.
Yes, sir. Mm-hmm. How are you? Hello? Hello?
Yeah, I can hear you now.
Okay. It's good? Can you hear me?
More or less, yeah. Yeah. How you doing? How's life?
Okay. Do you know anything about quantum entanglement?
A bit about the flux capacitor, but not much.
All right. I'll keep looking. Thank you. Hello.
Can you repeat it? I didn't understand the question.
I said, was the Muawiyah and Aisha war together, or was it like separate? Like Muawiyah had a war first.
Understandable. You know what's interesting, right? You know how you can debunk the anti-Semitic claims, right? If it was really anti-Semitic based, why didn't they go to the Holocaust Museum in the Netherlands?
Now where they'll kind of try to act like there's not all these videos coming out.
From his first term, I think he's gonna use them as leverage. He's not gonna actually put the
Hello. Hello.
Such a horror, dude.
Hello.
Hey.
Hi.
Mr. Slave.
Yes. Do you guys
You're
know?
friends with Abu.
Mm-hmm.
You're friends with Abu Hassan and Saint Venant. Oh wow.
Mm-hmm. How do you see that? Oh, mutual friends.
Mutual. Yeah.
Mm-hmm.
Abu Hassan's like Ashari or something like that, bro.
What is
He's
Ashari?
like
Abu
the
Hassan
anti-Wah-
Ashari?
No, Abu Hassan. No, Abu Hassan. One of the guys that We know.
Wait,
'Cause it
what
has
is
like a.
what does it mean, Ashari?
It's just retardation. It
Abwa.
translate from
Really?
Arabic to English. Yeah, it means retardation.
You think he's retarded?
No, he's not retarded.
So, but wait,
Yo,
I don't get it. Anyway, do you guys
hello,
talk?
my friends.
Hello. Do you guys talk about quantum entanglement?
About Diddy, Quanto.
No, we're talking about Diddy.
Oh, okay. All right. All right. Thank you. Bye.
Yeah, I'll be right back. My coach has arrived.
Hello.
Yo.
Yo, do you know quantum entanglement?
Yeah, I'm a physics expert. No, I kind of know what it is, but not really.
Mm-hmm. I think it's a cult.
Okay, great.
What do you think?
I have no opinion.
Do you wanna discuss it?
I don't even know where to begin discussing that.
Yeah, I have no idea what's quantum entanglement.
Do you want to know?
If you can like provide a very layman like description of it.
Sure.
Right.
Sure. So we can create two entangled quantum particles, whatever that means. Soon you'll understand. And you can get one and I get one, and then you go to one side of the visible universe, I go to the other side of the visible universe. We're both carrying now the two entangled particles. What it means is that when you measure your entangled particle, let's say you can only measure it what's known as up or down, whatever that means. So if you measure up, if you measure your particle and the result is up, then immediately you know that if and when I measure my particle, you know the measurement I will see is down. That's it. That's entanglement. Do you think it's magical? How do you explain this phenomenon? Do you have an explanation? Everyone, I mean, you don't, it doesn't
I don't know
help.
if it exists.
I'm just saying, it doesn't help to be a physicist. You can be a world-renowned physicist or a guy who just heard about this experiment, and both of you know the same. No one knows how this works. So,
But like, if you went to the medieval age and showed them an iPhone, they would think that was magic, right? So
wait,
you
but
know,
the question
it's
is,
all relative.
is there any? I mean, the quantum particle, it could be something really simple. Could be. It doesn't matter. I mean, whatever it is, you have it in a capsule, in a tiny bottle, and then when you apply the measurement, you get the result. Immediately, you know whenever the other guy does his measurement, you know what he's going to see. Do you have an explanation how this works?
No.
So it's magic?
I mean, maybe. Who knows?
Wait, you believe in God?
No.
So you don't believe in magic?
That kind of God. I never
Wait.
said I did.
Wait, what?
I didn't say I did.
Right. So if you don't believe in magic, then magic is not a possible solution to how this works.
Yeah, but I'm not arguing with you. You
No.
explained something to me, and I said, okay.
Let's assume hypothetically everything I said is correct. Let's assume that
Okay.
there is such
But
an
that's like saying
Let's assume everything I said is correct when I say there's a dragon outside my window. Let's assume that's correct. Dragons must be real, right?
No, that's a
Talking
hypothetical.
about.
No, I'm saying let's assume. Let's
I know it's
assume.
hypothetical.
What? I'm asking you a hypothetical. It's like assume a train leaves the station at 9 a.m. It's 10 miles an hour and so on. Is there a train? No. It's a hypothetical. It's a hypothetical. So let's assume that this story I told you is correct. That it is possible to entangle two particles, send them each to different parts in the universe, like light years apart. And when one particle is measured, instantaneously we know what the other measurement is going to be. And this always works 100% of the time. There's never been a failure. We never saw a failure in this test. That's the hypothetical. So the question is, how might such a thing work? How might
You said it's hypothetical, so
yeah, so now let's come up. Yeah, that's like with the train. I mean, assuming the train leaves at 9 a.m. at 100 miles an hour, and it.
my hypothetical answer is it just works because it's hypothetical. So
All right. So when people don't know the answer, they don't want to say I don't know. They don't want to think about it. They can't. If there's an easy way to win a debate, oh, it's because it's a hypothetical. I don't owe you an answer. I don't have to discuss this with you.
Taking among their photos, of course.
Yeah, there's like Serbian clubs and Croatian clubs and Greek clubs and.
Which is like something that needs to be abolished.
Yeah, it's the deep state. Yes.
That's what I'm saying though. Is like I kind of almost agree with them. Like if they hadn't, for example, so the way they would kind of go down, right, is my dad and mum a lot of the time would kind of make me feel like shite if I didn't just basically spend all of my free time helping them out with renovations and stuff. And I thought this was because they were lazy. I didn't realize most of the time when I was young, I was actually burdening them when I was there with them because I'm not very useful as a young kid.
Is that because and then like not let him continue because we should have recognized John Deere that like
useful with our lives.
Studying is for pussies. I hate
No,
mathematics. I hate
it's not.
physica and mathematica.
What are you guys? They
Me
listen to
boys
more
and
like.
couple stones into the hands. Square you play.
About negotiation. Yeah.
What?
Hi.
There we go. Hey, what's up?
Hey, do you know anything about quantum entanglement?
Maybe
Wait,
more
you
than
just
the
joined.
average. Yeah, good.
Oh,
Good
sorry,
point,
sorry.
Pep. Good point. No, you're right.
Do you want to talk about quantum entanglement a little bit?
Maybe later.
Okay.
Yeah, you guys, if you're both interested in that topic, yeah, you can talk about that. But can you tell me what is? But before you start, can you tell me what
Just
is
change my
that?
name.
Do you
I changed my name. Do you a
Please.
solid just means I'll do you a favor, and I just changed my name back.
Oh no, I don't mind that. Oh, the thing about no, like I don't really care. For me, it was more interesting is why you would want to trigger religious people. Like for me, that's more interesting.
Hi. Hello. Hello. Oh.
comfortable killing someone where there are situations that
so new and modern and ugly. They ruin.
Hello. Hello.
It's okay.
He's Turkish.
Okay, but that doesn't make you Turkish. Furthermore, how can your uncle be but your father isn't?
Hello. Hello. Hello.
What?
And he's dead. Anyhow. That is literally something unconstitutional and is treason. Why would
His internet is actually cutting out right now. Yeah.
Which you can
All right. This is hopeless. Flat Earth. The most dead server ever. Lofi. Most servers have a short lifetime. Okay. Friends who are online. Chinas. Probably at work. No.
My video posted in the general chat ready for that because I knew where he was going.
Hey.
Hello, Mr. Slave.
Hey, what's up?
I've got a paper on cults and quantum entanglement, where they say that apparently cults are quantumly entangled. Did you know that, Mr. Slade?
I didn't really understand what you just said. I'm sorry. What did you say?
Cults actually are evidence of quantum entanglement because they all have worshipping of a leader who it can't be explained why they believe this hypnotic leader, like Charles Manson say. And so they believe it's a form of quantum entanglement. So yeah, quantum entanglements do have a cult connection. Well done. You've advanced cults and
No, that's
quantum entanglement in both areas. You should write a paper. Okay.
Did I tell you I started a cult?
Anyway. Does anybody want to talk about entanglement?
Which you know nothing about, right? Okay, let's go. What else you want to talk about?
What do you mean? What else? Does anybody want to talk about entanglement?
What do you know about entanglement? You
can do it. Do it if you want there, Shill. Just wondering what you might have for him.
NASA
You're going to open a kettle of worms. You're going to open a kettle of worms, Phil.
Wait, NASA
How do you
Shill.
explain
he's going to explain how he sees solved entanglement. I've heard this before. You guys want to listen to it? Go right ahead.
I'm not.
Does
I don't
anybody
know.
want to talk about entanglement?
Oh,
No,
you know
apparently
what this
not.
sounds like. You know what this sounds like. Hello, would you like to help develop an app?
Yeah.
I
Hello,
wonder
would
if
you
I
like me to
wonder if
explain?
Mr. Slave gets. Sorry.
No, go ahead. Would you like me to explain something I know nothing about to you, please?
Do you have a paper? Have you written a paper on it?
Does this use the rubber duck analogy again?
Oh,
Don't
yeah, I've got that.
don't underestimate the power of the rubber ducky. 3 rubber duckies, you can prove the universe.
Mm-hmm.
You know. Terry, I was actually thinking about that there. That was 1 rubber ducky, Terry. You're short 2
No.
ducks.
No, there was 3.
Oh, okay. Don't you miss the good old times when Glory used to come in?
You're paying $4.50 a gallon for gas.
Good times, weren't they? Apart from the gas
I
prices.
thought I had those disabled. Was someone playing that down the mic?
No, that was.
I don't want to waste my time. I just really want to have a discussion about entanglement. I don't understand. I mean, it's so ridiculous. At this point, it has become so ridiculous. I just can't understand what they even have in mind could be the problem. What is the question?
From time to time, I give public lectures, and my very favorite part is the question and answer session that inevitably follows. The audience often comes up with interesting questions, but one of them sticks out in my mind. A young woman once asked me, "What is the weirdest physics phenomena that you've ever learned about?" Now, I don't remember how I answered her, but it got me to thinking, and I realized that I should have told her about a thing called quantum entanglement. It still blows my mind. Let's see if you agree with me. Broadly speaking, quantum mechanics is a physics theory that describes the behavior of atoms and even smaller particles. But quantum entanglement allows for weird quantum behaviors to be seen on sizes as big as people or even larger. So just what is quantum entanglement? In an earlier video, I talked about how the behavior of a subatomic particle, like a photon or an electron, is described by what is called a wave function. Brushing over many details, the wave function governs the probability that you will find the particle in a particular configuration. Before you make a measurement, you can't know, even in principle, what configuration the particle is in. To give a concrete example of what I mean by the word configuration, let's use the direction of the spin of a particle. Now, there is a quantum weirdness in that when you measure the direction of the spin of a particle, you first have to pick a direction, and then the outcome will always be either.
Why is that weird? I don't know why that's weird. That's my first question. Why is that weird? That's true for any measurement. For any measurement, you have to pick a protocol. Whatever the protocol is, you have to pick a protocol.
Either in the direction you picked or exactly opposite. It can't be anywhere in between. So if you pick a measurement direction to be horizontal, the measurement of the spin direction could be left or right. It couldn't be up or down, forward or back, or any direction except for right or left. On the other hand, if you decided to measure in the vertical direction, the only outcomes of your measurement would be up and down. Left and right would be forbidden. It's certainly counterintuitive, but it's just a weird fact.
At the end of the day, any test you have to decide a priori what are acceptable measurements. I mean, whatever your measurement is, you have a protocol. You're always limited by the protocol. And you're limited, whatever you're measuring. Let's say you're measuring if a person is happy or sad. Okay, there's nothing in between. You could say, oh, how happy are they? Okay, but there's nothing, so there's a scale. So you could say, you could always have a finer and finer and finer scale. With quantum mechanics, you can't. Okay, I guess that's true. But we know why that is. It's because at the end of the day, there is a minimal transfer of energy because of Planck's constant. So at the end of the day, quanta of energy has a minimal value. And so when you pass an atomic or a quantum object through a magnetic field, it can only go up or down, for example, because the minimal interaction, that is the most minimal interaction. It either goes up or down. That is the most minimal interaction. There's no less than that. There is no there's no less than that. That's the minimal. Isn't that right? I mean, we know that that is the definition of the word quantum. That's exactly where it comes from. Anyway,
of life in the
this is not even the issue.
quantum world. Now, prior to the measurement, the wave function might say that the spin axis of the particle could be in any direction. Indeed, the most popular understanding of quantum mechanics says that the spin direction actually is.
I don't care about popularity. That's literally a logical fallacy ad populum. What do you think, and can you defend it? Why do you tell me what the most popular something is? Anyway, that's obviously ridiculous, what he's going to say.
Is in all directions allowed by the wave function. It's only when you make a measurement that the wave function collapses and the outcome
Obviously, that's ridiculous.
becomes real. If you'd like some more information on wave
Obviously, this image is ridiculous.
functions and how they collapse, that other video might help. Now, what would happen if you had two subatomic particles? If you're like me, you'd think that they'd both be governed by an individual probabilistic wave function, and they'd be totally independent, with the spin direction of one particle having nothing to do with the spin direction of the other, and both of them being in all directions until a measurement is made. And that happens with four possible outcomes: two wave functions and two probabilities with all combinations of up and down. However, it's possible to prepare two subatomic particles so they both are described by a single wave function. That's what we mean by entangled. Two particles and a single wave function. You do this by taking a parent particle, which in our example has zero spin.
You don't have to say wave function. That I don't know what that means. That's not a physical thing. So I'm going to just ignore. When you say wave function, I'm just going to ignore what I don't know what you're talking about. I don't know what you're talking about. How the waviness of a particle has anything to do with our discussion. The fact that it's a wave, I don't see how that's relevant. So all that's important is what you're about to explain.
And let it decay into two particles. Spin is a conserved quantity, which means that it can never change. So if the parent particle has zero spin, then the two daughter particles have to have opposite spin. If one has a spin pointing left, the other is right.
That's pretty straightforward. We don't need to know about the wave function.
If one is up, the other is down, and so on. When you add the two, you get the zero that you started with. So that's the simplest example of a pair of entangled particles, which is to say two particles with opposite.
And the name entangled here, again, it's an overkill. All you're saying is because of conservation of angular momentum, they must have opposite spins. That's all.
Opposite spin and a single wave function that governs both of them. Okay, so now we're getting somewhere. The entanglement doesn't depend on the two particles being close to one another. As long as the two particles don't interact with anything, you can separate them by feet, miles, or even huge distances, and the two particles are connected by a single wave function, and the two particles will have opposite spin.
And by the way, we could simulate this with actual physical particles, objects. It doesn't matter what size they are. We have two objects that have some correlated or entangled, their states are entangled. You could do this with literally two basketballs that you spin them in opposite directions, but you don't know which is which is pointing which way. Or you could have a right and left sock or right and left shoe. Let's go with a right and left glove. So there's a right and left glove, and you mix them up, and then you gave one to one person, the other to the other person, and they don't know which is which, and they went off. When one is going to look at that's a little different though, because it's a little bit different. A better example is if I give you. Anyway, it's a good example. So you take two particles, they're spinning in opposite ways, but you don't know which is spinning which way. Okay.
Now, remember that one of the key facets of quantum mechanics is that the quantum world is intrinsically probabilistic. We can't know, even in principle, the outcome of a measurement before.
That's not true. That's true for that is a true statement, period, for the universe. Maybe even for every universe, every conceivable universe. 1 second. Wow, that's early for her. So it's like 8 a.m. Let's see what she says. Hmm. I want her to just create a room for me on politics. Hmm. He talks to her like she is his slave. That's not good. Hmm.
before we make it. So suppose we select one of
So that's a true statement for any test we ever run. We cannot know what the answer is, not even in principle, before we do the measurement. There's nothing strange about that, obviously.
the two particles and pick a direction to measure the spin. Say we pick horizontal. The measured spin will be either right or left, each 50% of the time. We could have selected the other particle to do the measurement with the same result, 50% right and 50% left. The real weirdness arises when we measure the spin direction of both of the entangled particles. Say we measure the horizontal spin direction of this particle over here on the left, and the measurement says it's to the right.
All right, then we know the other one is going to be to the left. Why is that strange? I mean, this is completely mechanical, right? Let's assume particle 1 was pointing at the right hemisphere of the universe. Okay, then we know particle 2, wait. Sounds perfect. What sounds perfect? What sounds perfect? What sounds perfect? What? I don't know. Hmm. What sounds I don't know what she means sounds perfect. Anyway. Hmm. So let's assume particle 1 points at the right hemisphere of the universe, and that's why we got a measurement to the right. That makes sense. This means particle 2 is pointing at the left hemisphere of the universe. That's why it's always going to measure to the left. That's it. What else do you want to know? I mean, that's completely mechanical.
Then we know that the outcome of the other measurement, it will be 100% of the time left, 100%
Why is that strange?
of the time. That means that the information that one of the two particles had a measurement made on it was transported
No, it doesn't. It does
to
not
the other
mean.
particle. And here's
No, it doesn't mean that. It doesn't. It's completely explained because of the fact that they were each pointing in different directions. You don't need to even think about this problem. This is not even nothing to think. There's nothing to think about.
the spooky thing. We can measure the spin direction of the two particles in quick succession, so quickly that we measure the second one before any conceivable information.
Why do you want information to travel between them? All right, she made it. Politics. Maybe I'm the last. There it is. Hey, can you talk? Okay, it doesn't matter if you cannot talk, it's fine. Hello.
Hello, are you a wit?
Excuse me?
Your picture looks like kind of like a witchy picture.
I don't know
Do
what
you
that.
believe in magic?
No, I don't believe in magic.
Oh, okay. You said quantum entanglement is BS.
Yes.
Okay, what are you? What are you, like some kind of quantum physicist?
Yeah, you could say that.
Okay, what do you know about quantum physics that makes you think string theory is not
No, I didn't
real?
say. I'm not talking about string theory. I'm talking about quantum entanglement.
Quantum entanglement. So you don't think string theory has to do with quantum entanglement?
I don't know anything about string theory. I honestly don't care about string theory. I barely care about quantum entanglement. For now,
And
let's.
you say you know about quantum theory,
So do you?
quantum physics.
It doesn't matter. I don't want to become the subject of the discussion. So, with your permission, do you want to talk
Uh-huh.
about? Do you want to talk about quantum entanglement?
Yeah. Yeah, where do you want to start with that?
So there's a video I posted in the side chat from
Okay.
Fermi Lab by Dr. Don Lincoln. And so in the video, he describes that we can create.
Spooky action at a distance.
Yes. So he says we can create two particles that have opposite spins. Are you familiar with
Okay.
this?
Yeah, that's the quantum entanglement. That's how we process what is it called? We do those those things that in the computers that are supposed to be quantum based, right?
I don't know anything about quantum computing. I'm just talking about entanglement for now.
Okay, well, yeah, the spin of two atoms, and when you put them in a superposition and they're directly connected to each other, that thing that you're calling the uh, spooky action at a distance, that is how quantum computers process information.
Yeah, I'd rather not discuss superposition nor quantum computers. I just want to talk about
We're,
quantum.
we're,
Hmm.
okay, sure. I mean, you want me? We're talking about a subject, and you literally, I can't talk about any of this other subject matter other than like this one narrow branch of you understand about it.
Well,
It's gonna be okay. Let's hear it. I'm not gonna respond much because I'm just gonna be listening, I guess.
okay. So Professor Don Lincoln, he says that we take a parent particle with spin 0 and we let it decay into two particles, two daughter particles, each with spin with opposite spins. I posted the image in the side chat. So far, so good. Do you understand what's going on thus far?
Yes, everything is computing in my brain so
Okay.
far.
Okay. I'm playing it in another tab. Um, okay, then we take the two particles and we separate them across the vastness of the universe. We put one, let's say of the planet, we put one on one side of the planet and the other one we put on the other side of the planet. Again,
Yes, spooky action at a distance.
I posted the image in the side chat. Now we don't know.
You're gonna say like
Mhm.
no. I'm sorry. Go ahead. You
Now
don't know what.
I'm right. I'm just posting as I'm watching it in real time. I'm posting the images so that it's as clear as possible. I'm explaining it with with images. Anyway, and now we're going to measure both particles simultaneously or one after the other. It doesn't matter. So, and we need to pick a direction of measurement. So let's say we measure horizontally. We're going to measure the particles horizontally. So far, so good? Are you there?
Yes, I feel like I'm listening, but I feel like you're going very slow, and
Yeah,
it's
yeah.
hard to keep up with.
Yeah,
It's so slow.
because I'm sorry, I'm posting images
Yeah,
as
yeah.
as we're doing it. So I'm watching it and posting, watching.
Okay,
So it's
no
taking me
problem.
a little time. Um, so we can either, I guess, measure particle one. If we measured when we measure particle one only, 50% of the time it measures the outcome of the measurement is to the right, 50% the outcome of the measurement is to the left, and the same for particle 2. If we measure,
Hmm.
yeah, so it looks like it looks like a flip of a coin.
Yeah. Okay.
Now here comes the crazy thing. This is the crazy thing. Theoretically, that's the crazy thing. I don't see how it's crazy. To me, it's obvious. And here it is. So let's say we measured horizontally particle 1 to the right.
Hmm.
Then we know with 100% probability that particle 2 will be measured to the left.
Okay. Yes. Yeah. That's okay. I'm following you so far. So, where's your contention with string theory?
No, I keep telling you, I have nothing to say about string theory. The name of the room is quantum entanglement is BS. We're only
Oh, that's
discussing.
right.
Mhm.
Okay. Well, yeah, it's quantum entanglement. So, if you're saying that this is like BS right here, what you're looking at,
No,
what
no,
you're
no,
showing me?
no, no. So he says, so Don Lincoln says that this is weird. That this is weird. Do you think this is
What?
weird?
No.
What's your explanation? What's your explanation for this?
That's how the particles work.
So why does he say that this is weird?
I don't know. I trying to understand how a person thinks is more complicated than just trying to observe how reality or nature works.
Okay, but
Getting
this
into the
is
minds of men is way more complicated for me. I don't
okay.
know
Okay,
why he would think that.
okay, but we're talking about all of mainstream physics. Everyone thinks this is weird.
Okay, I don't. Yeah, I don't agree with a lot of mainstream science because I think it's a lot of conclusions they draw is retarded. So I don't know. I don't know why mainstream thinks this is weird. I think they draw a lot of dumb conclusions.
Hmm. Okay.
I don't know why mainstream science thinks this is weird. I wouldn't be able to tell you.
Hmm.
I don't agree with a lot of stuff.
Okay, then
I
you
think this is logical and it makes sense to me. I don't see anything weird about it.
can you explain to me how this works? Can you explain to me how particle 1 measures?
They're directly connected to each other still through this entanglement. It's quantum entanglement. But you're saying
What do
that
you mean?
string theory has nothing to do with the particles
Why do
being
you
entangled
why do you keep mentioning string theory? Stop. We're talking
because
about
the
entanglement. You switch.
yes,
We're
because
not
the
talking about.
entanglement is you don't know what string theory is. The
Okay, okay.
entanglement of two
All
particles
right.
is
Does
directly
anybody?
correlated
All
to
right,
the
right. Okay, okay. I'm sorry. Does anybody else want to talk about quantum entanglement and not string theory?
you don't okay. Nobody else here knows what the hell you're talking about other than me. Unless somebody does, please speak up now.
Yeah. Anybody? Please.
Can I ask the mind if he's familiar with the Copenhagen theory of quantum mechanics?
The Copenhagen theory, if you refresh my memory just a little bit, I can definitely tell you I know what you're talking about, but by name, it's hard for me just to give you the
So my question is,
theory.
so the way I described, Sarah, did you hear my explanation of this video by Dr. Don Lincoln? Were you listening?
I was kind of zoning out. I think I should just watch the video.
Yeah, you can go watch the video. You only need to watch half of it. Just up to the part that he says that blew Einstein's mind. I don't understand.
But the mind, basically, I was in a chat with Objects is Real in his Wolfgang Smith chat.
Okay.
And I asked him if he likes his quantum mechanics stringy or loopy, and he said both have been disproved, and that he's an advocate for the Copenhagen theory. And so I just thought I'd let you know that there's someone out there who likes the Copenhagen theory, and I wondered what that was.
So you didn't ask him?
He's partially wrong. Quantum loop gravity was disproven, but string theory is still standing.
Okay, Loki, do you want to talk about quantum entanglement?
Maybe. Yeah.
Okay, can you look
It's
at the...
interesting.
Yeah, can you look at the side chat? Can you look at the pictures that I posted? And maybe you can go watch the video from...
Okay. And since there is another person in here, before I stop talking, I want to ask Loki a question. Do I have any validity in saying that quantum entanglement is directly correlated to string theory?
No.
It is correlated to string theory,
Thank
but
you.
It doesn't come from string theory.
I know. I'm saying that there's a direct
What do you
there's
mean
a
by
direct
correlate?
connection between the two.
Yeah, there's a direct
theory,
connection
basically.
between all physics.
Anyway,
Oh my God. The semantics.
Okay. I'm discussing exactly the video that I posted a link to the video, and there's images that I posted from the video in the side chat. And I have a very straightforward question. Nothing weird. I just don't understand what Don Lincoln is saying that blew Einstein's mind. I don't understand what is confusing. So if somebody can explain to me what's confusing, if somebody wants me to explain what Don Lincoln says, I can explain what he says. I just don't understand what's confusing.
Spooky action at a distance is not a thing that is not just understandable. If you think that that's just something that is easy to comprehend, it's because you were spoon-fed this knowledge. Like
basically
it's
nobody really
understanding.
knows.
Wait, one at a time.
So
Yes.
in string theory, if we talk about string
No,
theory,
no.
in string theory,
He doesn't want you to
I-
bring up
He
string
doesn't
theory.
want to
I tried
talk
to. I
about
already
string
tried to.
theory.
Yeah,
I already tried to explain to him.
string.
He doesn't want you to talk about. Yeah, he said no string theory talk if you want to talk to him about
Yeah,
it because
we're
he's
just-
only talking
We're talking
quantum
about
entanglement. I already had this issue with him
Yeah,
already.
we're talking about a specific
That's good.
video. There's a video that I posted in the side chat that and you have to watch it to the half or look at the pictures that I posted, or if you want, I'll explain the video again. And I'm just asking what is, like he said, it blew Einstein's mind. I don't understand what blew Einstein's mind.
And again, like you said, you can't use string theory to try to explain what he doesn't understand.
Correct. We're talking about
So,
quantum.
so one thing I don't understand here is these diagrams, because spin can be either up or down. It cannot be anything else. Spin
It
can
could be in a
either
state of
up or down.
superposition.
Spin
I'm sorry,
can
what?
be
It could be in a state of superposition.
No. Spin.
Yeah, so in
hold on.
superposition, it is
That's the
either
third
up
state.
or down.
That's in an isolated quantum system, though, right? Like,
Wait,
so
one
that's
second.
almost doesn't exist.
No, hold on. So you have to decide which way you're measuring. Like, let's say you're measuring horizontally, like in one of the images in this video, he ended up measuring horizontally, meaning left or right. When you measure left to right, you can either get left or right. 50% of the time you'll get left, 50% of the time you'll get right. That's what he
Yes,
shows.
I know that, but spin, quantum spin, is interpreted as either up or down. So
No.
that's
No.
when we describe.
Yes.
Yes, it
That
absolutely is.
that is
When
how
we
it's
describe
described.
quantum spin, it can be either up or down. Other than
No.
that, we don't know if it is up or down.
No.
That is called superposition.
No. Look at the pictures that I posted. It depends on what
I
direction.
did. No, it doesn't.
I tried to explain to this guy already.
So
It does
if
not
you
depend on the direction of measurement.
if you measure right and left, you still get up and down.
Yes, it's called up and down. If you measure right and left, it's the same as saying up or down.
Yes.
It's still up or down
That's
spin
fine.
because spin is called up spin or down
That's
spin.
fine.
Okay, the act of measurement, I would have to argue, has an effect on that which is being measured, that has been observed.
Yeah. Can you explain to me?
Yeah, because of the particle interaction.
Yes.
So okay. So I don't see why you need that, right? So if you measure the left particle, then immediately you know the measure. I mean, if you measure the left particle and it's to the right, then immediately you know that the other particle is going to measure to the left. Why? I mean, there's no you don't need to share information, right? When a particle, when you measure it, so if it's pointing, let's say, to the right hemisphere of the universe, right? A particle can either be pointing at the right hemisphere or at the left hemisphere, right? The universe, let's say, is like a sphere. So a particle can either be pointing at the right hemisphere of the universe or at the left hemisphere of the universe, right? It doesn't have any other option, right? You can imagine a particle spinning in any direction that you want in spherical coordinates. But at the end of the day, you can split the spherical coordinates into two hemispheres: the right hemisphere of the spherical coordinates and the left hemisphere of the sphere.
Where are you going with this? Because I think you're just saying things and you don't really know what you're saying at all. What are you trying to say right now?
So a particle can
Information's not being
either be pointing at the right hemisphere or the left hemisphere. So let's say the particle 1 is pointing at the right hemisphere. So when we measure it, it's going to measure to the right. And now we know that the other particle 2, therefore, must be pointing at the left hemisphere of the universe. Therefore, 100% of the time, it will measure to the left. That's it.
Yeah. So basically, he's describing the way that the two particles are entangled, that when you measure one, you get the exact same measurement for the next one. Now, when you and I think you're trying to say that when you like measure the second one, it'll always match what the first particle, if it was measured before the second one, like direction it was. But the first particle's measurement is random, is down to randomness. So I would like to bring something to the table which is like not repeating like how it works, because I think everyone here knows like what I just outlined and what you just outlined. Right. I think my theory is that the two particles, when they were entangled, like the process of entanglement, like reset them at like a state where they're like identical to each other in terms of determinism, and then even when you separate them, they're like, when you measure them, they're like, from that moment onwards, they like kind of like did a thing that was like identical to each other even when separated.
It's interesting though, because when you prepare an entangled system, it's an isolated quantum system, and so it's inherently random or probabilistic, and so it's like that's very interesting, because I agree with the logic of what you're saying. That would normally make sense. But it's
I'm
even more
basically
mysterious than
saying,
that.
like, if you had like a ball, if you like took a basketball and just spun it, right, and then took another basketball and spun it, but you had like a dot drawn on the basketball somewhere,
But
and then you randomly put your hand down on the top of the basketball and
Sarah.
paused it from spinning, the dot would be facing a random direction, right?
Yeah,
If
that's
you
kind of
take both
yeah.
balls
Wait,
and
little bit.
spin them at exactly the same time,
wait,
and then put
Sarah.
your hand down on the ball,
Wait,
if like all things were equal in terms
wait,
of forces
Sarah.
in the surrounding environment,
Wait, Sarah. Hold on,
yes.
hold on. So the way we're creating these two particles, they are in exact opposite spin. They're in
Yeah.
random. They're good when they get created. They get created in a random spin direction, but these two particles are opposite spin. It's some random direction, but the left and the right are opposite spins. The particle
Right,
one.
like a mirror. I would still describe them as like identical, but it's like a mirror image
Yeah, in
of
the
each
mirror.
other then.
Yeah,
Okay,
yeah, definitely.
It's like when I
that's
look in the mirror, I'm seeing an identical image, but it's just a mirror image.
well. The idea is that
The
there's
opposite, yeah.
in this universe there's conservation of angular momentum. So if the parent had zero spin, then the two daughter particles.
Okay. No, let's not. So spin, quantum spin is not angular momentum.
Yeah. You don't know what you're talking about. I'm sorry.
No, I'm repeating the video. This is if you look.
So
Okay.
the video is false.
So in the
If
video,
that is what he
video.
says, if he compares angular momentum to quantum spin, he is spreading misinformation. That is incorrect.
Okay, it doesn't matter. The point is that the spin of the daughter particles must add up to the spin of the parent particle. So since the parent
Okay.
particle had spin 0, therefore the spin of the daughter particles must be opposite. Okay, but it's random.
What?
Okay, that's fine.
But it's random. It's in some direction. We don't know, like if we look at particle 1, it's
What?
pointing in some random direction, and particle 2 is pointing in exactly the opposite direction. That's a
Okay,
given.
so this is the fourth time you said this, and I'm gonna have to just ask again, like, what are you trying to get out here? Because you said that quantum entanglement isn't real, and you're over here like presenting this claim, which is giving credence to quantum entanglement.
No. I mean, I'm saying quantum
Is it real or
entanglement.
not?
No, it's BS. It's a nothing.
It
Okay.
is.
It's a nothing burger. I mean, I don't know what else to say.
So
I mean, it's
so then why are you talking about this for like the past 2 hours? You're saying how non-real it is, but you keep on like talking about the exact
no. I
like
never said that. I never said that. So he shows.
ideology.
No,
So
if you,
in what
no. I said, look. I
what's
said,
actually
hold on.
happening then?
No. You gotta let me respond. You cannot dogpile me because I don't want to waste my time. So if you look at the images that I pasted, the last image, Don Lincoln says that blew Einstein's mind. All I'm asking is what blew Einstein's mind. That's all. Just tell me what is supposed to be surprising.
The
That's all.
spooky action at a distance. That is
Yes,
unusual.
that's
Yeah,
what Einstein called it.
the
It's
fact that
literally the name Einstein gave it. Spooky action at a
Okay, but
distance.
so
Because
I'll
you're measuring one particle, and the spin you get from that one particle, you know instantly that the other has the opposite. Of
yeah,
that.
but I'm
while no
explaining.
information was
Yes, I
transmitted
understand. I
as
understand.
well.
So, but here I'll explain to you again how it works. There's nothing spooky. There's nothing magical. Really, very straightforward.
You don't fully comprehend what you're saying right now. You have an
Mr. The
idea
Mind,
of what
Mr.
that
The
means,
Mind,
but you don't know what you're saying.
Mr. The Mind. Let me just talk.
I think
No,
what
Sarah.
he's saying
No. Wait,
is
Sarah.
that there's an explanation that means it's not a mystery.
Exactly.
Hey,
Exactly.
Sarah.
A
How
very
you doing?
simple explanation. So the explanation is that each right. Let's think about particle 1. Particle 1 is spinning in some direction. Now, in this video, he says particle 1. When we measure it, we see that we measure to the right. That means particle 1 was pointing at the right hemisphere of the universe, right? You can think about, right, the particle 1, before we measured it, we could have imagined that it's pointing at an arbitrary direction in spherical coordinates. It could be pointing anywhere, some arbitrary direction.
Here.
But we can split the spherical coordinate system. We can split it down the middle with like a vertical plane. So we can have a right hemisphere and a left hemisphere, right? The spherical universe, we can split it like in our minds into the right hemisphere of the universe and the left hemisphere of the universe. Now, particle 1, we measured it and it was to the right. That means it was physically pointing at the right hemisphere of the universe. That means particle 2 was definitely pointing at the left hemisphere of the universe. And immediately now we know in what direction we're going to end up measuring particle 2. There's nothing interesting. This is mechanical. This is simple mechanics. I don't know. What's the question? Why?
Okay, I get what
It's
you're
absolutely
saying.
not
It
mechanical
isn't.
because if it was mechanical, we could predict exactly which particle will have which spin.
No.
That's why it's called superposition, because it is impossible to predict.
No. I'm not trying
He's
to.
saying they're related to each other. It's
Yes.
mechanical, not that it's
Yes.
related to the surroundings. It's a
Yes.
bit like here's an analogy. If you take an apple and with the chef's knife you just whack it down the middle, right?
Yeah.
The two ends will fly off, right?
Yes.
And imagine if they flew off like in a mirror image to each other. Then you look at where one's landed on left, how many meters away, and you look at, and then you can just know, okay, I know where to find the second part of the apple.
Basically. Yeah. So I mean, we know.
Now, why did it take me 5 seconds to explain what you've been explaining for like 10 minutes?
I'm dumb. Anyway, so I'll repeat again the explanation.
Wait, let's see.
Wait,
no,
Sarah, one
please don't.
second. Sarah, but
Please don't.
Sarah, with all due respect, you understand it. I want to make sure everyone else understands it because I want.
The more you explain, the less they'll understand it. Just let Loki respond right now.
Wait, what do you mean? He doesn't understand. He still thinks that
what's his response to what I just said?
It's
Wait, Loki.
superposition. The
No,
fact
no.
that we cannot.
No,
the
no.
fact that
Loki,
we
you
cannot
don't
know
understand.
what it is.
No.
Don't interrupt me. The fact that don't interrupt me. The fact that we do not know and we cannot know or predict what it is before we physically measured it.
I'm not talking about
makes
that.
it superposition.
Okay, right, Loki, he's not talking about particle A. He's talking about particle B's prediction is based on particle A.
Exactly.
And that's not surprising because they were sent off in different directions at the point of separating the entanglement. But the entanglement itself put them in relation to each other.
Exactly.
In like the same spin, if you will.
Exactly.
Like not spin,
Opposite.
in the same sort of like opposite. No, in the same.
The arrow represents the spin.
Like.
Yeah.
No. What? Okay, this one I'm trying to say. Listen, it's literally the apple, right? When you chop it in half, the two sides fling in opposite directions, right?
No, Sarah, you're confusing them. I don't want to have analogies. People usually
get.
Yeah, I don't like analogies. Anyway, so Loki, I'm not saying that we should know mechanically a priori before we measure particle 1. We should know its direction. I'm not saying that. I'm saying once we know particle 1 points to the right, right? So we know it was spinning towards the right hemisphere of the universe. Then we should.
So does that mean the universe is right-handed?
No, I'm not talking about that. No.
He's saying, why is it so surprising that it would be matched? He's saying, why is it so surprising that particle B matches in the opposite direction particle A? That's not surprising. The surprising thing is
no, there's no surprise.
Nothing really.
Yeah,
exactly.
It's just
He's saying, of course it would match.
The surprising thing for Einstein, to answer your previous question, was the superposition. It wasn't anything about the particles transmitting data instantly over whatever range, or the fact that they are polar opposites. It's not that. It's the fact that they were previously in superposition.
Yeah, remember God doesn't roll dice. That's the whole point. Is like
Well, God's not real, anyways. So move on.
Anyway,
that's
if you
that's
It's an
watch,
analogy.
if
We
you
live in
watch,
a
no, no,
determined
that's
yeah.
what
physical
Einstein
reality.
said.
Anyway,
Einstein was a hidden local variables guy.
no,
He
we
thought
don't
there were
even need.
hidden
Well,
local
We don't.
Einstein
variables.
was Jewish. He was Jewish, and he married his cousin,
And
and
he turned out to be wrong about that, as we know.
and
And so there
Einstein
is
is
such
What
thing.
actually.
what does
I have to mute this
superimposition mean? What
Like
does
you put it on
superposition
top
mean?
of, like
Sarah,
you
I'll send you.
superimpose.
How do you
If
say
you
it?
put a square above a circle, it's
I
gonna
have
be a
mute them.
square
I'm
on
sorry.
top
I
of a
forgot that
superimposed on a circle. That's
No, Loki,
superimposed.
what word did you use? What word did you use? Say it again.
Superposition.
Sarah, I sent you.
Superposition.
Yes.
That just means that
What does that mean?
before we measure particle 1, it could be pointing in any arbitrary direction. So we treat it as if it's actually pointing in all directions at once.
No, that's incorrect.
it's
We don't
the
treat it
fact.
as if it is pointing in any direction, and even trying to explain superposition linguistically is quite literally impossible.
Okay.
That's the
But
reason
Anyway,
why people do not understand the
but
double
it's
I don't
getting
slit
at
want to.
true
theorem.
I don't want to
randomness.
discuss
The only
superposition.
way you can
I don't want to discuss.
explain
No, please,
superposition.
let's not.
Okay, just
No,
let me
I don't
finish.
want to
The
discuss.
only way.
No, we have the
No,
room.
I don't care. The
No, the
only
room is
way
for
we
quantum
the
entanglement. We're
only
discussing. No, we're only
okay. Well,
discussing.
quantum
We're only
quantum entanglement,
No.
superposition is a major part of
No.
quantum
No.
entanglement.
We're only
How don't you
discussing.
get that?
No, we're discussing just quantum entanglement. Anyway, the
You
point
cannot
is.
discuss a topic and ignore a major part of the topic.
No, Sarah.
It's not how it
It's
works.
not. It's not important, Sarah. It's not important.
Yes,
I
it is.
explained
It
it already.
absolutely
It's not
is.
important. No, it's not. It's not. It's
You
not.
didn't.
No.
You explained it incorrectly.
Sarah actually understands exactly my question. Sarah is already on my side. So, Loki, let
You
me try.
already answered your question.
Okay, let me try to convert you to my side. So, can you explain to me what is confusing about this experiment?
Superposition.
No.
That's what confused Einstein. Yes.
Look at the video.
Yes.
Go watch the
Yes.
video. No, go watch the
The
video.
video is fucking incorrect. It quite literally compared physical
Okay, we're watching.
angular momentum to
okay.
quantum spin,
Wait,
I
which
think
is
we should listen to
fundamentally
Loki
incorrect.
because of his accent. He's got the type of accent that knows stuff about quantum mechanics. I think we should let him explain superposition.
It's not about the accent, but
It
okay.
is. It's only the accent. It's a postcode lottery, and you won.
Sarah, I sent you a
So-
friend request. I appreciate that you figured it out so quickly. You're brilliant.
Yes, I am. I understand exactly what you meant.
So try to explain to Loki that there's nothing surprising in quantum
I did,
entanglement.
but you got to do it with an apple. You got to do it with an apple. You got
No.
to chop that apple right down the
No.
middle.
Okay,
The
so
apple,
so
two
let's clear
ends
up the
fly off.
confusion. Let's use another analogy. Imagine you fix two guns pointing in opposite directions to a spinning wheel. Imagine you spin the wheel and it randomly, both guns at the same time, randomly shoot out a bullet, but that spinning wheel is completely concealed. You cannot see it. Now, let me try to make you understand why superposition is so important here. Before you measured it, imagine those two guns pointing in different directions are the particles. Before you look at them, you have no idea what's happening. That's superposition. You have absolutely no information about them.
Yeah, that's
why I say superposition is so important.
Yeah, but there's nothing interesting in this experiment. So again,
It doesn't have to be interesting for it to be informative.
No, but
Okay, but listen, do you know bullet A? If you know where bullet A is, you'll automatically know where bullet B is. That's not surprising because they come off the same thing.
It's supposed to be the most, right? The video starts when Don Lincoln says, I was asked, what is the most unbelievable, weirdest thing in all of physics? And he says, let me tell you about quantum entanglement. Quantum entanglement makes no sense and no one can explain it. And I don't even understand the question. Like, this is the most straightforward thing in the universe. Nothing is more straightforward than quantum entanglement.
The only claim you can make is that it makes it's predictable. But like, no, as in you can predict particle B from particle A, but like you saying it's bullshit needs to be substantiated. No,
Fine.
saying it's bullshit needs to be
Fine.
substantiated further.
That doesn't matter. The point is, Sarah, that exactly as you said, we can predict particle 2 once we know particle 1. That's obvious to anyone who has a brain. So why is the entire physics community, why do they think quantum entanglement is something so special? I don't get it.
Because of what happens before you try to measure them. That's why I'm telling you, superposition is the biggest part of this topic.
Quantum quantum entanglement.
Part of this topic.
Quantum entanglement.
Yes,
The name of the video. Look at the name of the video.
Quantum entanglement.
No. Look at the name of the video. No. The name of the video is quantum entanglement.
Superposition.
No.
Yeah,
quantum
I
entanglement.
don't give a shit about what the name of the video is. If quantum entanglement is the topic,
we're discussing
everything
quantum entanglement.
concerning quantum entanglement, everything concerning that topic is a part of the topic.
Okay, once you know that particle 1 points to the right, why are you surprised that particle 2 is always measured to the left? What is so surprising about that?
Not the surprising part about
Yes, it is. Go listen to the video. Yes, it is. This is what he says. Go listen to the video. Go listen to the video. This is what he says.
The video guy was like surprised easily about the wrong thing. That's what Loki's saying.
Well, but I just want
That's
look.
what I'm saying.
No, I look, Loki. No. All I'm saying is
of measurement in this experiment. The effect of measurement in this experiment is not surprising. The surprising part is what is happening before it, because before
it's just random.
Superposition,
No, it's just random. There's nothing surprising. There's nothing surprising about superposition. That's obvious. You flip a coin, it's going to land left or right 50% of the time. That's not surprising. That's the universe. The question
Even
is...
that what you said is incorrect.
What?
Even that is incorrect. It's 48.5% of the time for tails.
What? Anyway...
You have to be, the point is you have to be precise when you talk about these topics. You have to include everything. You can just say it's bullshit and just hand wave it. It's not how it works.
I have no idea what you're talking about. Look, the fact that 50% of the time the particle is measured to the right and 50% of the time the particle 1 is measured to the left, there's nothing surprising about that. The question, what's surprising to me is, what is mind-blowing, what Einstein, according to Don Lincoln, why was... Hold on, wait, one second. No, one second. One second. Wait. The question is, why did Don Lincoln say that this blew Einstein's mind, that there is communication? Wait, one second. Wait, one second. Wait, Loki, no, I'm in the middle. Loki, you already said that. Loki, you already said that. Loki, you said that. Loki, you said that many times. Loki, you said it many times.
Yes,
I already told.
I know, because
that's not. But I already answered. I answered. It's not interesting.
No, you didn't.
Particle
No,
1. Particle 1. No, there's nothing interesting when you flip a coin and 50% of the time we get heads and 50% of the time we get tails. That's not interesting. Yeah. So a particle 50% of the time is to the right and 50% of the time is to the left. That's not interesting. What's interesting?
You cannot even compare a classical mechanics problem. Probability.
Why are you surprised? Wait, what? Okay, what do you expect? Wait, so what do you expect? So when you measure, wait, what do you expect? Wait, so what do you expect?
I expect you to take into account.
What do you expect? What percent? Wait, what do you expect? What measurement do you expect for particle 1? If not 50-50, what do you expect?
doesn't matter. That's
What
the
do you
point.
expect? What do you mean it doesn't matter? What do you expect? What do you
anything.
expect besides
You
50-50?
cannot, there is nothing to be expected.
What do you mean?
If it's
It goes, sometimes
50-50
it
in
goes
all
up, sometimes it
cases,
goes down. What do you expect besides
if it's
50-50?
50-50 in all cases, there is nothing to be fucking expected.
What do you mean? But we know the phenomenon. Half of the time the particle goes one way, half of it goes the other
Yeah,
way. So it's
doesn't
50-50.
matter.
Why would you think?
That's not the part. That's not the part of the problem that interested or shocked Einstein.
So what did?
You don't
So
know
what?
you're
Yeah. So
talking
what
about.
exactly? So what shocked Einstein? Tell me what shocked Einstein. That's exactly what I'm saying. So what did shock?
Superposition. You know what it is. Do you know what that is? Do you know what superposition even is?
Okay, just tell me the answer. What shocked Einstein? Tell me the answer.
Superposition.
Go
shocked
on, go on,
Einstein.
go on.
The
I'm listening. I'm
fact that
listening. I'm
the
listening. I'm
fact-
listening. Yeah, go on, go on,
Shut
go
the
on,
fuck up.
go on, go
The
on.
There's
fact
true randomness
that
in the
the
universe.
particle is neither top spin nor bottom spin during superposition. That is what shocked Einstein. That is what produces random results.
Right.
Because
True
he believed
randomness.
that nothing in the universe is truly randomized.
What? So
Like,
what
he believed there were-
so wait, so what did Einstein expect particle 1 to show up as? If not 50-50? I don't get it.
He
He didn't
expected that
expect
whatever it showed up
anything.
as,
He
it would be
didn't
determined.
know about that prior to the fucking experiment and the invention of quantum mechanics. What are you talking about?
Here's what he expected: there to be locally hidden variables, which ultimately made everything deterministic, and he
Wait,
turned out to be wrong.
can somebody explain to me? Okay, so either you explain to me what blew Einstein's mind, or we all agree that this experiment was
fact that
completely
he
as
was
expected.
Can
wrong.
Sleeves repeat what he just said? Can Sleeves repeat what he just said? Because I think that's the key.
Superposition ultimately, in its relation to Einstein having his mind blown, is basically talking about true randomness in the universe. That's why he said God doesn't roll dice. What he's saying is that because he believed in local hidden variables, which are basically variables that would turn the Schrodinger into nothing, and you wouldn't have a probability distribution for a solution. You would have a value, which is what we get in classical mechanics, right? So the point is that Einstein believed that local hidden variables existed, which would make true randomness not a thing. Everything would be deterministic. He was wrong.
Sarah, do you want to come with me and trigonometry to my server?
Sure. But I want to stay here for now because what Sleeves just said.
No, it's nothing.
Sleeves basically said. Believe that.
Right.
Yeah, I'm sorry. I
And
left a
he
mistake. Anyway, look. So I'm looking at a video, right? I presented the video that presents quantum entanglement, and there's supposed to be something spooky, something mysterious, something weird, and I don't get it. Like once we measure particle
the
1,
video maker is a product of alcohol fetal syndrome. The video maker didn't get what was the spooky part. Like the video maker just is declaring obvious. As you said, we can completely ignore the video.
Sarah, you would you you're amazing. I mean, Don Lincoln is an actual experimentalist at Fermilab, and this video is a production of Fermilab, United States Department of Energy, and European Space Agency. It's a major channel, almost 1 million subscribers. It's a very sciencey channel.
Wow. Do you know why they are so wrong about some of the concepts they share in there? Why
Wait,
they
what do you mean they're
don't
wrong? Wait,
include everything they should?
wait, you agree?
The fact that they
Wait.
compared the fact that they compared angular momentum to quantum spin.
Okay, I'm
Do you
not.
know?
Okay,
Well,
okay.
that is a
Do you
common.
know?
Oh my god.
Just listen to me and answer the question. Do you know why they are so wrong about some things?
Go ahead.
I know why.
Because they are trying to simplify fucking quantum mechanics for the general public on the internet. Not everyone just has the ability to just go and read papers or learn quantum mechanics
Do you find?
or learn algebraic geometry and topology.
Do you find it surprising? Do you find quantum entanglement weird and surprising and spooky?
Yes.
Yes,
it's
of
random.
course.
Can you explain to me what is
The randomness,
the
the fact that it
randomness?
is
What do you
completely
mean?
random. Yes, one second.
Why is that?
is
Why
true
is that
randomness?
surprising? What do you expect if not randomness?
Well, because true randomness is a
I'll
mind
be
fuck.
back in a
Because
second.
how could a property like that exist when we live in a universe of cause and effect? But there is no cause and effect relationship between
Wait,
an
when you
input
wait,
and an
sleeves.
output of a random
Wait, sleeves.
process.
Wait, sleeves. When you flip a coin, you don't expect randomness. You don't expect 50-50?
Oh, that's pseudo randomness, which is determined by the
Fine.
initial conditions
Fine.
of the coin flip.
Fine. Yeah. So particle one is pseudo random. Well, yeah. Fine.
Oh, that's not what they're saying. That would mean that there are local hidden variables, which Bell's inequality was. The Nobel Prize was won in 2022 for
No, no, no.
proving Bell's inequality
This is from 4 years ago. This video is before the Nobel Prize. Let's ignore that. So, according to this video, he says that quantum entanglement, the way he explained it in the video, is the weirdest thing in physics. Can you explain to me what's so weird about it?
True randomness. That's the weird part. The fact that there is no connection.
Yeah, he doesn't
between the
say.
input.
That's not what he says. He doesn't bring up. He doesn't. I mean, he just says
You
that.
just asked me.
What?
You just asked me though. So what do you mean? That's
No,
not
I'm
what he
asking
said?
you what Don Lincoln, what Professor Don Lincoln, and what Professor Einstein found mind blowing about this. I'm trying to understand.
We told you at least 30 times by now. I don't
know if I can
know
explain.
what's so surprising. Einstein heavily believed, Einstein strongly believed that the universe was completely deterministic, meaning that you could predict anything with perfect precision, with independent variables. However, in quantum mechanics, you cannot always do that because of that randomness. That is what is mind blowing. I don't know how you don't understand that.
But that's not what Don Lincoln says in the video.
Yeah, because Don Lincoln didn't know that.
What do you mean? I'm asking
No,
you. I'm
he
asking you to
probably did
explain.
know that.
I'm asking
He
you to.
probably did know that.
I'm
But the problem is that he's trying to explain quantum mechanics to the general public, and the general public does not understand what randomness in physics means.
How is it different than a
There is
flipping of
no
a?
way to concretely and explain quantum superposition, so he didn't do it because it's quite literally impossible. Other than with using mathematics, which the general public does not understand.
Anyway, he did explain superposition, and he brought it up, and the multiple arrows that you see in the images, that is exactly how he presented it, that it's pointing simultaneously.
Well, that is not
One second,
superposition.
Loki, let me finish.
Superposition is
Loki, let me
linguistically
finish.
inexplainable.
Loki, you gotta let me finish once in a while. So the way
I can't let you finish. I can't let you finish if you're spreading misinformation, which they put into their fucking video because the video is misinformative and stupid. You can't just watch a fucking video and think you know what quantum physics is and what superposition is.
Loki,
Other than in algebraic
Loki,
mathematics, it is impossible to describe superposition.
Loki, I'm just trying to understand this video to the half point. So can you explain to me what this video, why Don Lincoln says Einstein found entanglement to be mind blowing?
I just told you because of
Because he
superposition,
had
because it is
alcohol,
not deterministic.
fetal
Do you know what
syndrome.
Okay,
deterministic
Loki, enough.
means?
Loki,
You
enough.
know what
Let Sarah
deterministic
speak.
means?
Loki, let Sarah speak. Sarah, yeah, go ahead.
Oh,
You
sorry,
know what
I was just telling a joke. Sorry,
Because
Loki.
no,
Sorry,
your joke is
everyone.
very,
okay.
your joke is more interesting. So wait,
Do
Sarah,
you know
wait,
what
Loki, wait,
deterministic
okay,
means?
Loki, stop, Loki, stop.
Just answer the question. Do you know what it means?
Yeah, of course.
Deterministic.
I know, yeah.
What?
It doesn't matter.
What does it mean?
I'm not,
Yes, it does. It
no.
absolutely does.
You
If you
can
don't know what
explain. You
deterministic
can explain.
means, I
Yeah.
cannot explain to you
I'm not
what
interested. Loki, I'm not
what
interested.
bugged
Loki, I'm not
Einstein with
interested in Loki.
superposition and
I'm not
entanglement.
interested. I'm not interested. Loki, you either explain to
Well,
me.
yeah, it's quite obvious because if you are not interested in what deterministic means, then you cannot understand what bugged Einstein about entanglement. I don't know what what did you cram into that fucking brain? How don't you understand that if you don't know some of these words, you cannot get an explanation of what the topic is?
Basically, the video maker, Dan, whatever his name is, he thought that Einstein was surprised about thing A, right? So he said that in the video. What Loki's saying is that actually Einstein was surprised about topic B, and that the video maker is just misrepresenting Einstein's shock.
Yes, exactly. The thing Einstein was surprised by is that the universe at the quantum scale is not deterministic, which means that you cannot predict something with total precision, which means that the universe is fundamentally random, and that is what Einstein was against, and that's what surprised him. Einstein didn't like quantum physics. He
It's
didn't like
literally
the randomness.
it's literally why there's another famous phrase by him, a quote, which is God doesn't roll dice. That's how you know that that's what he means. He's talking about the randomness, the superposition of quantum entanglement.
Anyway.
It is.
Okay, anyway, so everyone agrees that according to what I explained, right? So once we measure particle 1 that it's pointing to the right, then we know that particle 1 must have pointed to the right hemisphere of the universe, which means particle 2.
No, that's the superposition part of it. It never. We don't know if it did or didn't, or it both pointed it in both directions simultaneously. We don't know. That's superposition. That's what bugged Einstein. It's true randomness. When it's
Only
in
when we measure
superposition, that particle is neither pointing in right direction or a left direction. It is neither, nor is it both.
The Schrodinger equation gives you a probability distribution as a solution, whereas we're used to getting a value, right? So if the answer to a question is a probability distribution, that's not really a good answer, is it? Because it's basically saying all answers are correct. It's just within these probability constraints. But when we measure stuff, that's never the case. It's only one or the other, one of them, right?
Anyway,
Yeah, and you
so
can never predict it.
okay, wait a minute. So me and Sarah, we agree that it makes sense that once you measure particle 1 to the right, now you know that particle 1 was pointing at the right hemisphere of the universe. And since particle 2 has an equal and opposite spin, it means particle 2 must be pointing at the left hemisphere of the universe. Let me just finish. So then we know that particle 2 must be measured to the left. So there's nothing surprising about this. This is completely mechanical.
Yes, after the measurement. After the measurement, nothing surprising. But before the measurement, you don't know. That's superposition. It's impossible to tell. That's what bugged Einstein. That's true randomness. You don't know. If you could know, if it always did point to the right and the other to the left, then you could deterministically state that it is either pointing to the left or the right, and you could calculate to which side it is pointing. And you cannot do that because quantum mechanics is not deterministic.
Wait,
It's not an equal and opposite spin.
Wait, you
That's
look, you're creating, you have a parent, look at the images. You have a parent particle from which and then it decays, and two daughter particles are created with some random opposite spins, some random spin. This is like the flipping of a coin.
No, it's not. That's the thing. When you flip a coin, if you knew everything about that coin, everything that is influencing it, you could precisely predict what face it is going to land on. You could predict that it is going to be tails, if it is going to be tails, or the other way around. With quantum physics, you cannot do that. That's superposition, and that's the interesting part. That's randomness. It is neither, the particles aren't pointing to either side during superposition.
Yeah, there is no cause and effect relationship between the initial conditions and the outcome. That's why it's fucking crazy.
One second.
Causality doesn't.
Okay, wait. Let
no
me
causality.
wait 1 second. So hold on. I'm asking Loki a question. Look, Loki, look at the image. It says you have a parent particle with spin 0, and then it decays, and now you have two daughter particles that are spinning in some random direction but opposite spins, right? Well, do you find this surprising?
No, the fact that they are spinning in the opposite directions wouldn't be surprising because you know that only after you measure them.
Yeah.
Do you find the fact that they're spinning in a random direction surprising?
The fact that it is random is surprising, but it isn't random as soon as you measure them.
Wait.
When you measure it,
So the fact that wait
know...
1 second, Sleeves, 1 second. So Loki, you agree that the fact that they spin in a random direction is not surprising. You agree with that?
You cut out.
The fact that the daughter particles spin in a random direction, do you think that is surprising?
Yes, absolutely. That points to quantum mechanics not being deterministic and being purely random. That's why we have statistical probability distributions in quantum mechanics and not determined values.
Hey, Gamma.
Oh my god, I just got jump scared.
Sorry. Were you listening?
Yeah, I was.
Do you understand my question?
Not really. I was just using it as background noise.
Anyway, so I simplified quantum entanglement even further. It's like now it makes even, I mean, it's even more mechanical than ever, and I don't understand why anyone thinks it's anything. Can I please explain this to you so that you tell me if I forgot to take my crazy pills?
Yeah, sure.
1 second, let me ask Amber if she wants to join us, because I'm tired of that server. That is such a terrible server. Amber, do you want to come with us? So we're going to Globe. Sarah, you want to come with us to the Globe server?
Yeah.
What's the globe server?
I'll send you
I'm just checking up.
I'll send you
I'm here.
I'll send you a thing. Here is a thing.
Is it a flat Earth?
No,
thing?
it's anti-flat
No,
Earth.
it's the opposite.
Yeah, you can come join us.
Anti-flat Earth. Okay.
Yeah, Amber, you want to come?
Nice.
Anyway, let's go. Anyway, so Gamma, you listening?
Yep.
Okay. So, let me try and find the files. The files, pictures, screenshots. Let's start from here to here. There you go. Okay, told Amber where to go. Okay, so can you? Okay, let's. So you can look at the images. So if we look at image, the first image, or you can look at my stream if you want to look at my stream. Or I'll share my. I'll share my desktop. No, I don't know. Anyway, so if you look at, okay, so you have a parent particle, and then it decays into two daughter particles that are spinning in equal and opposite directions, but some random direction. So far, so good, Gamma?
Yeah, yep.
So can you repeat everything up until now?
What, say again? Sorry, I'm typing in chat.
Okay, so you have a parent particle with. You want to look at my stream? Did I give you my stream? I didn't give you my stream. This should be my stream. Yeah, that's my stream. You want to look at my stream? You want to share my stream? No, you can't share my stream. You can share my stream. Anyway, so do you want to talk, Gamma? Or are you busy?
Kind of busy. Kind of busy. I'm sure Terry will entertain it, right, Terry? Yes.
Oh no, I was listening in before with Mr. Slave, people trying to tell him that no, maybe just as much as what is out there for mainstream knowledge, but Mr. Slave just does not want to listen.
Amber, did you change your name or did they change your name? Oh, you cannot talk? Okay. Okay, I'm leaving. Amber, let's go to my room.
Right?
I'm not sure what you mean by that particular statement.
It's an analogy.
Yeah. Well, what is your point, though?
Like, so, okay, so in this, in the entangled state, if I was to randomly spin particle A in the opposite direction with my fingers, would the particle B randomly start turning the opposite direction as well?
No.
The same action would be imposed on the entangled particle.
No.
Despite distance.
No. No.
Yeah, I'm thinking no as well.
No.
I'm thinking
No,
once
what?
they've detangled.
I don't know why he's saying no. It's not clear.
So I heard from Sabine Hossenfelder that she said literally they never tell you that when you change the spin of one of the particles, it does not affect the spin of the other particle.
Then what is the actual effect of entanglement?
That's exactly my question. For me right now, I don't understand. I've given up. Like entanglement is a complete Go ahead. Go ahead.
No, pool.
me check
Okay, imagine
quantum
pool balls. Do you who plays snooker or pool around here?
Everyone.
I've played pool, not snooker.
Everyone played.
Okay, I've taken 2 pool balls and I've put them in the middle of the pool table, right?
Mm-hmm.
And with the white ball, I've shot it into the middle of them. They spring off, right? If I do it in a certain way, the two balls, you can predict where one has gone from the other. That's quantum entanglement, basically.
Basically, but
The entanglement part is putting them together in and hitting them in the right place.
But
And the de-entanglement part is them going off.
no,
And
there's
the
no
measurement is
there's no de-entanglement. There's no such term.
no, I mean
Disentanglement.
well,
No,
disentanglement.
there isn't. No one has ever used. I've never heard anyone talk about that. Look,
I'm pretty
look,
sure
Well, I
if
mean, I
I'm
should
pretty
write a
sure
paper about it. Then.
if one exists, the other
No,
probably
I'm not
exists.
judging.
The
I'm
antonym.
not saying. I'm just saying. Look, Sarah, you keep creating analogies, but really, the analogies are. I don't think you don't need to create analogies. Just use the original.
Hey, by the way, disentanglement is a real concept. Of
Fine,
quantum
fine. I
physics.
said I'm not judging. I'm just saying. Sarah seems to
Well-
always be creating analogies, and she understands the original experiment. So, Sarah, just explain the original experiment. You don't have to dumb it down. Like
Okay.
I think you end up
Okay.
because
Well, this is what I wanted to say.
Well, but I think you're
The
being a little
disentangled
unfair to her.
particles.
No. I'm on
The
Sarah's.
disentangled particles.
I'm
Right,
on.
listen. The
No,
disentangled
Sarah, one second.
particles.
Sarah,
If I was to
wait.
poke
Sarah, one second.
one and
Sarah,
slow down its
Sarah,
spin,
Sarah, one
would
second.
particle B also
No,
slow down? Yes or no?
No. They have no. You cannot influence. No. You cannot. As far as I know, of course. not.
Okay, that's all I wanted to say.
Yeah.
That's all
So
I
then
wanted to say.
why if that is the answer, then what is the significance of
I
quantum
don't
entanglement?
know. I don't know. Right? It makes.
That's why his title is Quantum
I'm reading the
Mechanics is
page.
bullshit.
Exactly.
So here's what it says. Here's what it describes here. I'll read it slowly. Let's try to untangle this. No pun intended.
Wait,
Quantum entanglement is the phenomena of a group of particles being generated, interacting, or sharing spatial proximity in such a way that the quantum state of each particle of the group cannot be described independently of the state of the others, including when the particles are separated by a large distance. Okay.
I know
that's
you
just
don't
the
like
opening.
analogies, but another analogy would be encryption, right? So I've got a number that I put through a mystery.
No, Sarah, no,
a
stop.
mystery.
Stop with the
You know what I've
analogies.
got to say?
No,
Very intelligent.
Sarah,
It's
Sarah, stop.
awesome.
Sarah, stop.
It's awesome. It
Stop.
makes me cleverer than Einstein. You should let me
Stop.
say it.
No, stop with the analogies, please. The entanglement is so simple, and I just want an answer. Here is the video. Here is the experiment. It's really very straightforward. Tell me what I'm missing. The end. That's it. No, you don't need to create any more analogies. It's so simple. Why are you creating analogies? And I know the answer. I know the original experiment. I hear your analogy. It's a bad analogy. I've tried to come up with better analogies. I can't. It's so simple. Just don't dumb it down. Just explain the original experiment until they understand it, and ask them, okay, so what's so special about quantum entanglement? Because for me right now, it's a nothing burger. I'm not saying it's wrong. I'm just saying it's a nothing burger. There's nothing mind-blowing about it, even potentially. What is supposed to be mind-blowing about it? What is supposed to be weird? He starts the video saying, what is the weirdest thing in physics? What's so, I don't know what's weird about this. There's nothing weird. It's weird that you think it's weird. That's weird. But that's sociology.
I don't think it's weird.
I don't think it's weird.
And Albert Einstein didn't think it's weird. He thought that superposition was weird.
Yeah, sure. Yeah.
Randomness and true randomness.
Yeah, true randomness is weird, of course, because no one has ever seen the flip of a coin. That's so weird. Anyway, so
There's no such thing as randomness. Yeah.
No,
it's
me and
not
Sarah
practical.
are joking. We're laughing at Loki that he's like made no sense. Anyway,
Who's Loki?
the guy that was
I'm not
yelling.
doing that.
Oh, okay.
Then Sarah explained to me what this video says. It blew Einstein's mind. What blew Einstein? The video literally says that what blew Einstein's mind is that there is instant communication between particle 1 and particle 2. But my question is, why do you need particle 1 to talk to particle 2 or vice versa? Why do you need them to talk to each other? They spin in opposite directions. Therefore, they're always going to give you opposite direction when you measure them. Ta-da! Roll the credits.
No, they're in superposition.
No. Superposition and quantum entanglement are not mutually inclusive. So why are you mentioning superposition?
Yeah.
Because when you have
these people, they want to mention superposition.
I'll explain it. Hey, retard, shut up. Quantum entanglement, you have an isolated quantum system. That's why that's how they're entangled. Because when you measure one, they're no longer entangled. That's how you know information about the other one. They're in superposition. They are in an isolated quantum system.
No, superposition is when something is in two positions at once. It's not two different particles.
Right.
So, for example, if I have
that's what an isolated quantum system means. It means that there's nothing measuring that system, and therefore it has the properties of super.
Yeah, such as the double slit experiment. The electron is in some kind of superposition until you measure it. Then the wave function collapses and it is observed in a single position.
Okay, we're talking about a different experiment. This video is about two particles spinning in a random but opposite direction. We measure particle 1, and immediately we know in what direction particle 2 it will be measured in the opposite direction. And this video seems to claim that that is bizarre. That is weird. That is the weirdest thing in physics, Professor Don Lincoln says. So my question is, why? Why is it even interesting? It's not even interesting. It's so boring. There's nothing interesting. Quantum entanglement is wieners.
Yeah, I don't know who did that.
Amber did it. Amber, stop. Anyway, so I don't know. I don't know what to say. I mean, I've been researching quantum. I've been researching quantum entanglement for a while, and I'm trying to figure out what's so special about it. It seems to be a complete nothing burger. It's. Can everyone here explain?
I guess it's just not known.
Wait, what?
I mean, clearly it's not fully understood yet.
Wait, what's not understood? What don't you understand?
Fully understand.
No. I mean,
understand.
Science. Our some knowledge of science does not yet completely understand quantum entanglement, quantum superposition. That's why there's so many questions about it. You talk to a physicist about this, they'll tell you that they're still trying to figure out. Okay, we have these observations, but we're not sure why it's doing that yet.
Wait, what's the question? Here, I mean, did you see the video by Don Lincoln?
I didn't ask a question. No.
What do you mean you didn't ask a question? You said you said
I
something.
did not just ask a question. I made a statement.
No, when I say what's the question, I'm saying like you said we don't understand quantum entanglement or something, right?
Oh, we don't understand what exactly is going on. Yeah, that's
okay. So I'm saying
quantum mechanics is not yet fully understood. It's a project.
Wait, quantum entanglement. Wait, do you have any question? Do you have any question about quantum entanglement?
No, why do you keep asking that?
No, you say there's something you don't understand about quantum entanglement. What don't you understand about quantum entanglement?
No, I said science has not yet fully unraveled the mysteries of quantum mechanics.
We're talking about quantum entanglement. No, we're talking about just quantum entanglement.
Quantum entanglement, quantum entangled. I'm including quantum entanglement in that camp.
Right. So I'm saying, what don't we understand about quantum entanglement?
That's it. That's exactly. It may be a unknown unknown. There are known unknowns, and then there's unknown unknowns. Things that we don't know yet. But if we don't understand, if for example, if
I'm gonna
we
have
can't
a
do
brain
anything we want with
aneurysm.
quantum,
What are you talking about?
why?
What are you talking about? Is there anything you don't understand about quantum entanglement? Yes or no?
Oh, of course, me, if especially because I'm not even a quantum physicist.
But just
but
yes
then
or no.
quantum physicists
No, just yes or no.
also
Wait, just
don't
yes or
know
no. No,
quantum.
just
Quantum.
wait. Just
I already
yes or
said.
no.
I already said yes. I already fucking said
Okay,
yes.
okay, okay. Then
Yes.
what?
He
Fine.
said
Quantum,
yes, bro.
but
Then
quantum
what?
physicists
Then what?
also
No,
don't know
wait, no.
everything about quantum
No,
mechanics.
wait. Then if you said yes, then tell me, what don't you understand about quantum entanglement?
I don't know all the things that I don't understand about quantum
No, no,
mechanics
no.
because I
Wait.
don't know
No,
what
no, no.
questions
Okay, I'll ask again. I'll ask again.
there are
No, 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 no.
to ask
No,
entirely about
no,
quantum
no, no.
mechanics.
Let me ask again.
All right. Hey. When I start answering, wait until I'm done speaking before you start saying, no. All right. Okay?
I'm
Just
just
stop that.
trying to save time. I'm sorry.
Now go ahead. I'm done.
Okay.
You gotta
So
follow the rules, dude.
no. Okay. So the question is there anything about quantum entanglement you don't understand? Yes or no?
I already said yes.
Okay, now, so there is something in quantum mechanics you don't understand. What is that thing?
Oh,
Sorry,
more than one.
what is that thing in quantum entanglement that you don't understand?
I don't even know the extent of the things there are to know about it that I do not know. There are unknown unknowns to me.
Okay. All right. I give up.
You understand? You can't
No.
understand that?
No.
Okay, let me give you an example. Let me give you an example. Hold on a second. Hold on a second. Let me give you an example.
But what don't you understand? So there's no such thing. I don't know what I don't understand. That's not an answer.
Of course there is, and I'm
No,
about
that's
I'm
not.
about to give you an
That's
example
not.
why.
No.
I'm about to give you an
No.
example
When you
why.
answer, when your
Absolutely.
answer starts with "I don't know," then you don't know. I asked
Yeah.
you, what don't you understand? What don't you understand? And
No,
you're
but
telling me,
I'm aware.
I don't know what I don't understand.
I'm not exactly, but no. I'm not aware of the full complexity of it. So, for example, let's say I'm a caveman in the
Okay,
Middle
never mind.
Ages.
Did you see the video?
Before
never mind.
I already answered that question too. So don't
Wait.
ask me the same question again.
Wait, what is?
So
Wait, I asked you if you saw the video.
hang on. Who's the mod in here? Yes, you did about a minute ago.
I
Who's
am.
the
I
mod in
wish
here?
I
'Cause this
was
guy's not
because
letting me talk.
I'd like to be
Mr.
able to hear
Slave,
some.
Mr. Slave, yeah, you can't just keep cutting me off here. Just let me get this example.
There are other
out, 'cause this is
people
very
in here that
important.
like to.
If you need to Google this, you need to, in science there are known unknowns and there are unknown unknowns. So let me give you an example of that.
No.
So for example, if
No,
I
I'm
was
not
a
interested.
here we go again.
I just
Here
want.
we go again.
No. I look.
Here we go
We're
again.
here to
You're talking
discuss.
to me right now.
No, just quantum entanglement. We're not here to talk about.
But it's
No.
very relevant.
No, it's
I
not.
answered
No.
I answered a
No, we're
question that you
watching.
asked me
No.
about quantum
No.
entanglement.
Just tell me if you
and
watched
you're
the
not
video.
accepting the answer.
No. Did you watch?
Because you don't I already
No.
answered that question.
What's
already
the
answered that
answer?
question.
I don't know. What's the answer? Did you watch the
I
video?
said no, and I said it several
Okay.
minutes ago.
Can I explain to you what exactly he says in the video? Please.
Only if you allow me to get my example out because it's very critical.
No, but I know, but the unknowns and unknowns. I even know who invented it. It was in a Senate hearing. I was there when it happened.
What do you mean invented it?
Somebody came up with this statement with the 4 possibilities.
That
it was, I think, Dick.
That's not a
Yes.
Yeah,
Yeah, it was Dick Cheney. Yeah,
thing.
it was Dick Cheney during the first Iraq War.
Okay,
in
then
the Senate hearings.
Then why don't you understand what I'm saying when I say
do.
that?
I didn't say I don't understand. Okay, listen.
But yes, you did. When you asked me what I don't
never,
know about.
I understand.
Hey!
I understand, but
You
I
asked me what
understand. Don't repeat. I understand. I understand. I understand.
Who is the mod here? Who is the mod here?
No, I'm not
Kamala.
a mod.
Guys, come on! What the fuck?
Kamala is a mod.
All right.
Mr. Slave, can you not be a
you're
Mr. Slave?
You're not letting us progress here, Mr. Slave. Just hang on. All right. So.
But let's not change the topic.
The whole room wants to hear this. Okay, Terry's trying to hear it. Maybe Sleeve Justice trying to hear it. All right. So let's say I'm a caveman in the Middle Ages before I have a sufficient telescope to really do too much. Right.
I'll be back later. All right. I don't want to waste my time. Jesus Christ. Oh, there's two people watching the drama. Oh my God, Jesus Christ. Uh,
Something that I don't know, and I don't know that I don't know it. It's an unknown unknown.
what about
That's what
what
I'm
you
talking
don't
about.
know that you don't know that you don't know? What about that? And what about what you don't know that you don't
That's a
know that you don't know that you don't
nonsensical.
know? Oh, it's nonsensical.
It's
Okay, let's
nonsensical
not
to
waste.
add a
Okay, okay,
third
whatever.
thing.
Let's not waste time. So, my question is, what is what don't we understand about quantum entanglement? Because whatever you don't understand, let me explain it to you. It's like very straightforward.
Oh, you don't understand dick about it is the problem.
Yeah, I
A
don't hear
lot.
what you
I mean,
just
we don't
said.
understand a lot about it.
Name what?
He said we don't understand dick about it.
Name one thing we don't understand about it.
Why the
Well, no,
particles
I
are
actually agree.
entangled,
I
for example?
agree. Actually,
I mean, the
I agree
particles.
with you.
Okay, so he
Actually,
said
it's
why the
quantum
particles
mechanics.
are entangled. So you don't
No,
understand
no,
why the particles are
you
entangled.
understand.
So when you have
That's
a
true.
parent particle and it decays into two particles, they must be spinning in exactly opposite spins in order to conserve angular
No,
momentum.
no,
Yes, yes.
you don't know what you're talking about. No,
They
no,
spin in
they
opposite
are in
directions.
superposition,
In
dog.
every when
Dog.
we
How
yes.
do you prepare an entangled particle? How do you prepare them? How do you get two
I don't
entangled
know.
particles? How do you prepare the
You
spin?
start
Yeah, you have
in
to have
the
a gauge.
video. You start with a parent particle. You let it decay into two daughter
Yes,
particles, and when it decays into
which
two daughter
are
particles, if the parent was spin zero, did not spin, and the two daughter particles do spin, then they must spin in such a way that the combined spin of the daughter particles must
yeah, but
cancel back to the spin of the parent, meaning they must be
it's not
spinning they
left and
must be
right.
spinning in opposite directions. However, both daughter
What?
particles must be spinning in some random direction. Random but opposite direction. That's the entanglement. And
Okay.
then you separate the two particles to opposite
Oh, that's
sides
not
of the
even right.
universe. And then you measure one of them. And whatever you measure, now when you measure one of them, it measures, let's say you measure horizontally to the right or to the left. Let's say the answer is it measures
Yeah.
to the right. Then instantaneously you
Okay.
know the other one is going to measure to the left. And that's supposed to be
Okay.
mind boggling. That's supposed to be the
That's
weirdest thing in history.
that's entanglement.
Yeah.
All right, but that
Guys,
if that if what?
remind
Hang on, Sarah. Now's not the time.
No,
If
let Sarah
if what
speak.
you just
No,
described,
no, let
if you
Sarah
just,
speak.
oh,
Let,
I was already
sorry.
speaking when she came in.
no, she
All
but
right,
she just came in. Let her just
I'm
say a
gonna turn
word.
down. I'm gonna turn down COD. No, I'm responding to what you just said. So if what you just said is accurate, then entanglement does not sound very significant. It's simply a property of the conservation of angular momentum.
Yes.
However, I don't know whether or not what you just said is completely
So
accurate.
watch
Sleeves, you
watch
seem
the
to be
video.
pushing back on
Watch
that.
the video.
That's not
Watch the
accurate.
video. It's
All right,
like
Sleeves, why is that not accurate?
Because when you prepare, the only way you can, because okay, think about what it means when you have something and two entangled particles. The whole idea being that when you have to measure one, which does something to the other. Well, what you did is you caused decoherence to the system, meaning they're no longer entangled, which is why
Okay, I
you're
get it.
measuring them and getting definitive values for their spin.
Okay, I understand.
Because
Yeah,
before they were in superposition, there was no left and
yeah. Let me
guaranteed
sharpen that
left and
for
right
you too.
spin. Yeah.
So I'm going to sharpen that for sleep. So this is part of the. This is related to the observer problem in the double slit experiment or other experiments. In order to measure a subatomic particle, you need to directly interact with it, which changes its properties. It collapses the wave function. So this destroys the entanglement relationship, or maybe not destroys it, but somehow otherwise affects it. And now your kind of results are corrupted because you, in order to, so for example, in the classical world, if I'm gonna observe something, like let's say Schrodinger's cat
okay.
experiment, for example. I don't know if the cat is dead. I'm still speaking. I'm still
No,
speaking, sir. I'm still speaking.
you're
I don't know if the
monologuing.
cat.
You're
I'm still
no,
speaking.
that's
I'm still
monologuing.
speaking.
No,
I'm
that's
Let
still speaking,
him.
sir.
Let
monologuing.
him
I'm
monologue.
still speaking.
No, there's a
I'm still
limit. All
speaking.
right, bye.
So
All right, enough is enough. I don't want to waste my time. This is too much. Okay, so This is absolutely atrocious. Like, I used to think that there's something interesting, but now I'm thoroughly confused.
We measure the horizontal spin of the other particle. We find 100% of the time that it's to the left. And remember that we did it so fast that not even light could have told the second particle the outcome.
What's so surprising? I don't get it. Okay, this is completely not interesting. Does anybody else find it not interesting? Teacher, without discuss. Okay, let's remove this. I've been wondering about the quantum entanglement for years. This is the best explanation. I love the guy. How many comments? 2,000. The most important educational, intriguing video. Watching it today. Newton's gravitation. Posted 49 seconds ago. Chaos worship. Let's try a different model for hidden variable theory. Quantum entanglement blew my mind. I want to get there. The very first time I learned about it, I dropped physics class. Love your video. I don't know what's going on. Really strange. This experiment. Whoa. What is going? Oh, that's so funny. I don't think the information is transported. What means when you entangle quantum objects, then you put them into a certain state. Then you can move the quantum objects apart. You don't know what state the quantum object, but you know, for example, the spin is to the left. The other must be. This guy has it. Because they have prepared this behavior at the time their information when they were close together. Information would be transported if when the objects are far apart and you change the spin exactly one object and the spin on the entangled object changes, but as far as I know, this is not the case. Exactly. From 3 years ago. Exactly. Wait, exactly. This guy got it. Higgs boson. Can I give my take on this? Okay, is this mine? From a non-scientist perspective, I'm a software developer profession. I use a simple analogy for the entanglement using two playing cards. The car. No one understands what's so strange. What I was trying to say in my rather awkward way is that maybe there never took. Oh my god. Reading the comments, I just realized that there is one rampant misconception on what is weird about the entanglement in the EPR setup. Let us clarify this point. If we follow EPR, we clearly see that the effects are not at all the problem. The problem is how the information that determines the expectations of these effects is encoded. I don't know.
But that
I'm
depends.
gonna
What does
prove
it mean to say? What does it mean to say the phrase "the edge of the universe"? The universe, the edge of
The
the universe is not a physical
particles.
barrier, is it?
All right. So, this is a weird video.
The first particle. That means that quantum information can travel faster than light. Yeah, you heard me right. Faster than light. That blew Einstein's mind, too. In fact, he co-authored a paper in 1935 with Boris Podolsky and Nathan Rosen that highlighted this problem. He also called this transfer of quantum information spooky action at a distance. This was one of many reasons why Einstein didn't like quantum mechanics. So what do we think about this phenomenon today?
I don't get it. What? What's going on? You're telling me about this experiment?
Does quantum information move at speeds faster than light? Yeah, it seems to. But it doesn't invalidate Einstein's theory of relativity because we can't control it.
You know, let me try. I'll tell you what to do. Let's go to PNR. PNR. Oh, there's many people now. That's good. So join to create. Let me see where. Okay, Mr. Slave. How do I change? Lock, unlock. How do we rename? Set name. Set name. Quantum entanglement is BS. Quantum entanglement. Okay. Okay, let me invite Sarah. Terry can come. Lori, I don't know if he's available. Where is what's Gamma? Gamma no hack and Amber. Okay. Okay, let me take this link. And let me post the images. Up until let's remove this one. And let's roll it back. Okay.
That means that the information that one of the two particles had a measurement made on it was transported to the other particle. And here's the spooky thing. We can measure the spin direction of the two particles in quick succession so quickly that we
Let me capture
quickly that
exactly. That's exactly what I wanted. So capture this. Okay.
we measure the second one before any conceivable information from the first measurement could have arrived. Let's be super concrete on this by remembering that the fastest thing in the universe is light. It travels a foot in a
Then this
billionth of a second. Now, let's take two entangled particles and separate them by 10 feet.
I don't want to go into the details. Then this.
It will take light 10 billionths of a second to travel from one to the other. So now let's get tricky. We'll measure the horizontal spin of one of the two particles and see that it's to the right. Then 5 billionths of a second later, we measure the horizontal spin of the other particle. We find 100% of the time that it's to the left. And remember that we did it so fast that not even light could have told the second particle the outcome of the measurement of the first particle. That means that quantum information can travel faster than light. Yeah, you heard me right. Faster than light. That blew Einstein's mind, too.
And this is the most important. That blew Einstein's mind. That it travels faster than light. Okay. Boom, boom, boom. I guess we can remove this and this and this. Too many uploads. You can only upload 10 files at a time. Okay. So only 10 files. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, up to Don Lemon. And then 3 more. Okay. Now we wait.
In fact, he co-authored a paper in 1935 with Boris Podolsky and Nathan Rosen that highlighted this problem. He also called this transfer of quantum information spooky action at a distance. This was one of many reasons why Einstein didn't like quantum mechanics. So what do we think about this phenomenon today? Does quantum information move at speeds faster than light? Yeah, it seems to. But it doesn't invalidate Einstein's theory of relativity because we can't control it. We can make both measurements and the outcome will seem random, and we'll only know that the two were opposite when we compare the measurements, and that information can be transferred.
Okay, 3 hours. I think we're going to stop.
No faster than the speed of light. So that saves Einstein's theory, which is a relief. Otherwise, I'd have to learn a whole bunch of physics. But it's still perplexing. How is it that quantum mechanics can travel so fast? Well, there were some people, including Einstein, who thought that this wasn't so mysterious after all. Suppose that you had a red and a blue ball, but you couldn't look at them. You grabbed nobody that heard about this. That was pretty much my reaction. The technical name for this more ordinary connection is called hidden variables. So the question is,
what's hidden?
How do we know that there's something new and different about quantum mechanics? How can we test the idea of quantum entanglement and compare it to the more intuitive idea of hidden variables? There's a long history of this, with a prediction in 1964 by theorist John Bell and a test in 1981 by Elaine Aspect, as well as contributions by many others. I'm going to forgo the history and the details of the mathematics of the predictions and just explain the measurement. We know that if we measure the spin direction of one particle, that the other one will be in the opposite direction. But let's change it up. Suppose that we measure the spin of the second particle in a totally different direction. How does that change things? Let's measure the direction of the first particle in the vertical direction, but the second one in the horizontal direction. That means that when you measure the...
Okay. So you measured vertically particle 1 and it came up. Then you know that particle 2 is pointing at the bottom hemisphere, anywhere in the bottom hemisphere. So when you measure it left and right, it's 50-50. You know it's 50-50 left and right.
The spin of the second particle, it will be either right or left. That's weird, but remember, that's how this works for quantum spin measurements.
Why is that weird? Okay. One second. Okay. Maybe I'll go. Okay. Let's finish up. I want to go make a protein shake.
Now, I'm going to simplify the discussion by only talking about the situation when the spin direction measured for the first particle is just up. We could be more general, include both up and down cases, but it's more confusing, and the answer is absolutely identical. If you want to do the general case, let me invoke the phrase that physics professors love and students hate, which is the exercise is left to the student. Okay, now let's get into both the quantum and hidden variable predictions. The first measurement is in the vertical direction, and it finds the particle has spin up. When you measure the spin of the second,
if you measure the other one left and right, so if you find this is up, that means this one is pointing at the bottom hemisphere. So it's going to be 50-50 on right and left.
second, you measure it in the horizontal direction, and you get right and left with equal probability. The first measurement gives you zero predictive information about the second measurement. It turns out that both quantum mechanics and hidden variables make the same prediction for this scenario. This is very different from if you made the second measurement in the vertical direction, because if you did, you'd get a second
Then it's 100% down.
measurement in the downward direction 100% of the time. Again, this is the same for both quantum mechanics and hidden variables. So now we're ready for the final bit, which is to look at all possible measurement directions for the second particle and see if the predictions are different for quantum mechanics and hidden variables. We will still assume that the spin direction measurement for the first particle is upward. And then
Second, I have a phone call. Okay, 1 second. Let me just send a message. Okay. All right. So particle. Okay, so yeah.
And then measure.
Now we're gonna do every angle by angle, every degree. Okay.
Spin direction for the second particle, starting upward and then slowly spinning the measurement through 360 degrees. This graph shows the predictions of how often the second measurement will be in the direction the second arrow is pointing. If the second arrow is pointing upward, we know that the second measurement is always downward. So that means the second measurement agrees 0% of the time. If the second arrow is
Mango, hello.
How are you?
Fantastic. How are you?
Also pretty good.
Excellent. Do you want to talk about quantum entanglement?
I mean, I'm not like an expert on that. I do remember the like, oh shit, I can't even remember what the word's called. Where they kind of proved it. But that's as far as my knowledge goes. So if you want to share, I will listen, but I don't have any hot takes.
Okay. I mean, so you can look at the side chat. So I posted all the information. So everything started when I watched a video by Don Lincoln at Fermilab. So Fermilab is like, have you ever heard of Fermilab?
I've heard of the Fermi paradox.
That's cool.
But no.
Yeah, so I guess it's both named after Professor Enrico Fermi.
Okay, makes sense.
Yeah, so there's a place called Fermilab. There is a particle collider at Fermilab, and Don Lincoln is a professor, doctor. He's an experimentalist, So they produced this video in collaboration with the Department of Energy. Fermilab belongs to the Department of Energy, and in collaboration with the European Space Agency. So it's a big deal. I'm not taking this video lightly by any means.
Why does it matter to you? Or like what's the implication in your mind?
The implication is as incredible as implication can get. I mean, nothing to me implies more or implicates more. Like what?
Oh,
Mm-hmm. What?
oh, so maybe I didn't I guess I was asking like
Mm-hmm.
because obviously there are people who
Mm-hmm.
present that quantum entanglement is real, right? So you this
Exactly.
information, the idea that it's not real, what's the implication? Like, why does that matter to you? I guess, like, what does it mean if that's the case?
So if all of the physicists in the world think one thing, and I think they're all wrong, so I don't. That's overwhelming. How could that be? I mean, we're not talking about a bunch of dummy dum-dums. We're talking about the people with the highest mm-hmm.
Oh no, sorry, I was just laughing at the
Yeah.
phrase.
So, right, we're not talking about a bunch of dummy dum-dums from a mental asylum that ran away. We're talking about people who study this for a living for the past 100 years, including Professor Einstein himself. Well, I don't know. I mean, the question is, whose side was Einstein on? It's not so clear that Einstein agrees with me or with them. Maybe he agrees with me more than with them. I need to read the original paper. But for now, Don Lincoln certainly seems to agree that quantum entanglement. I mean, he starts the video by saying, "What is the weirdest thing in physics?" And he claims this blew Einstein's mind about quantum entanglement. And to me, it's a nothing burger. There's nothing to it. It's simple. It's as
Should
simple.
I
Mm-hmm.
sorry to interrupt. I guess I'm
Mm-hmm.
as a layman here, should I just watch it or
You
would
can,
that
yeah, you can watch it at least, let's say to the half until he says that blew Einstein's mind, and then you tell
okay.
me. Yeah,
Okay, yeah, I think that would help me
for sure.
engage.
Yeah,
Cool. Give me a
yeah,
second.
yeah. Take your time. Um, you might want to mute me because I'm gonna be talking to myself because I'm streaming on another tab. It's up to you. Anyway, so okay, so he's going to do this this thing.
Is pointing at 90 degrees to the right, the second measurement can be right or left with equal probability. So it'll be to the right only 50% of the time. If the second arrow is pointing downward, we know that the second measurement always is downward. So it is in that direction 100% of the time. And as we go to 360 degrees, the pattern is reversed. It's very important.
Okay, so this is supposed to be weird. I mean, I don't get it. Well,
the pattern is reversed.
So, what is the difference? Is the straight line from the curved line? I already proved. Why would you assume a straight line over a curved line? I don't get it. So if I this has to do with the distribution. So if you have if this is spinning one way, let's say this is right. This is pointing up, so we know this guy must be pointing to the bottom hemisphere of the universe. Okay. So when we measure 0, we get 0. I guess 0 is top. So the pointing up is 0. So it's never going to be up. That's for sure. But then you tell me some of the time it's going to be here. What? Mm-hmm.
Um,
Mm-hmm.
Semi realized that my brain was not ready for all that information right now, but it was nice talking to you.
Okay.
Yeah.
See you
Bye.
later. Bye bye. Hello,
Hello.
Sammy. Yeah, what's up?
Not much. My head hurts. I'm tired. I need to go on a walk in like an hour or two.
Mm-hmm.
Because my legs are feeling better. 'Cause they hurt so much yesterday, so I didn't go on a walk.
Mm-hmm.
I wanted to go on a walk though.
Uh-huh.
I don't know anything about quantum physics. So like how is quantum entanglement bad?
How isn't quantum entanglement what? Bad?
Uh, yeah. Because isn't that what your thing is saying?
I'm still
The
trying to.
title?
I mean, you have to watch the video and explain to me the video. The video that I put in the
Oh,
side
there was a
chat.
video?
Yeah, you have to watch it.
Spooky actions at a distance?
Mm-hmm.
Ah, okay.
Hi,
Hi.
people.
Hello, Mr.
Mr.
Dot.
Slave. What up, what up, what up, what up, what up?
Mm-hmm.
So can we talk about like the political and economic state of the world right now?
Yeah, sure. What's the question?
China. China, we're gonna put tariffs on China. And it's gonna be like it's gonna fix our economy. I'm so happy that Trump's in the office right now because like he's gonna make everything so cheap right now.
Well, energy will probably become cheaper. If he places tariffs, everything will become, I mean, all the imports from China will become more expensive, but he says he's going to repeal income tax. So it's called PPP, parity purchasing power. That's what you have to compare. So the question is, relative to PPP, are things going to become more expensive relative to the fact?
Nah, Donald Trump is gonna fix everything. He's gonna fix the border. He's gonna deport all illegals, and he's gonna make the economy beautiful. And we're gonna have no transgenders in women's bathroom, and we're just gonna have a Christian nation and a Christian republic nation. That's what I want.
Are you being serious or cynical?
No,
He's
serious.
being cynical.
Well, Mr.
In
Nah,
terms of
Dot,
like it being a good thing. In terms of his belief that that's what he thinks the outcome's gonna be.
I converted. I converted to Trumpism and
I don't remember that. Why didn't you tell
Christian.
me?
Oh, it just happened. Like a couple of, I've been convinced of joining Christian nationalism and Trumpism.
It doesn't sound very genuine.
Yeah, but I mean, who have you ever heard of Trump or be genuine? You know, we're all
okay, but Mr.
pretty flawed.
Dot, Mr. Dot,
I think I'm pretty genuine.
wait, Mr. Dot. So I, if like I explained to you that it could work. I mean, I understand that you're
It
being
couldn't.
no, I understand that you're being cynical, but
But you don't understand. Like
Mhm.
Trump, look at Trump's last term. Like the prices were like very like they were. We could afford gas. Like we could afford living. Now we're just dying on the street, and we don't have money for gas and for groceries, and I can't buy a house.
Your money is going to wars, right?
Yeah, that's it. Yeah, our money's going to Ukraine. They're sending millions of illegals money
Well, as far as I'm
in
aware, no
bags.
cash is going to Ukraine. It's all money and
Yeah,
like
but
estimated
I
value of
deny that.
military
Now,
equipment.
now it's money going there. Yeah, it's money,
Okay,
money.
Dot, I don't know
No,
if you're serious or cynical.
no,
So,
for real.
I'm pretty sure
They
he's being
they're
disingenuous.
sending $10 billion to Ukraine and $1 billion to Israel, and it's just it's we have to save our country from this woke mind virus that's going on.
all right, Dot, I don't know. I don't know. I don't know if you're cynical or serious. I'm sorry.
Why do you think
What
I'm
are,
not serious? I
what
think
is you
this is.
what is you guys thought about that Algerian female boxer coming out as male? There was an Algerian female boxer.
I don't know why
Uh,
people give a
for
fuck about this stuff. Like, well, why do people
no
care? If,
Are you talking about the
people.
one at the Olympics?
Yeah, yeah, yeah. So,
I
so
don't.
when people said that she was a male, at that time they were gaslighted that no, she is a symbol of woman empowerment and all these things. And now it has come out that she is a biological male, and that is the, I think, biggest thing that this how should I say, nonsensical aspect of it is.
Can you give me a
I mean,
source?
recently there were articles. Okay, I will give you the articles.
Why is it
Algerian.
important?
It is important because it is a representative of the woke mind virus that this guy was talking about. How can a
yeah,
woman
exactly. Yeah.
participate in a world level, a global sport? Just how can a man participate in a global sport of women's peak performance? Like
Because
you don't.
before,
So
because before
there was a
transgenders, we were all so concerned with women's sports. Like we used to watch it every day. Like we, they're ruining it. It's like the average Republican watches at least 5 hours minimum of
Oh, he's being
women's sports
disingenuous.
every
Okay,
day.
all right. So you're being cynical.
Yeah.
It's
Okay,
so crazy, this
okay.
it's not cynical.
Dot,
It's
transgenderism.
just
Dot, Mr.
like
Dot.
this.
Wait, wait.
It is common
No, no.
sense. It is a common
Bubbles.
sense
Wait,
thing that
Bubbles. Or 1 second, 1 second. So, Dot, come on. Stop being cynical. Like, take a position so we can
Yeah.
talk to you. Like, I don't
I
want to
mean,
waste my
Sammy
time.
has talked to me. Sammy has talked to me already. Yeah, I'm a never Trump guy.
That's fine.
I'm
So
just joking.
be yourself. Like, be honest. Anyway, go on. So now that we know your position, everybody can have a normal conversation.
Sure. I was
Yes.
trying to be on the wrong side to
No, don't.
see if it makes sense.
Don't stop. You don't have to. You can hold your position. Ask me to hold my position, and we can have an honest discussion. We don't need to like. What's the point of
But there's no discussion to be had. I think we probably agree on most things. I don't think we.
possibly? No, I'm a Trump supporter, but I'm not 100% agreeing with Trump on everything. Far from it. But about like I can explain to you like his positions on many things. Some things I don't agree with him. Many things I don't agree. But
Who's Rella?
I don't know.
Why is Mr. Slave muted?
I'm muted. You can't hear me.
Can you hear him? I can hear him.
You can?
You can't hear
Yeah.
me. Why can't you
That's
hear
weird.
me?
I can't.
yeah, we can hear him. Yes, we can
You
Sometimes
can
hear
the
him.
hear him?
audio's weird. I've noticed problems like that where like all of a sudden just someone's
Oh,
audio
now I
stops.
can hear him. What the heck? That was weird.
Yeah, that's weird.
I thought like he just got like Okay. Well,
No, I created
now I
this
can.
room. It's my room.
Oh, that was weird. I thought. Yeah.
Hmm.
Okay. Now I can hear you.
Anyway, so Mr. Dot, or how can I? Do you have a name, a normal name?
Probably you would address him as Stewie because that's the image.
Yeah, Stewie. Stewie's fine.
Okay, Stewie.
Before that, it was Kamala,
Kamala.
and Kamala lost.
Okay, Stewie, let's
Yeah.
go. All right. Do you have any questions? Do you want to tell us why Trump is wrong? Why you're never Trumper?
Oh, I mean, I think he doesn't have any policies. I think
Wait,
he
but
stopped the peaceful transfer of power.
wait, but what is it called when you give like a long list, like just one item? Let's discuss. What's the give us your
When you give a long list, it's called a gish gallop.
gish
You
gallop? Yeah,
overwhelm them, and then you proclaim that you won because they couldn't answer all of your points.
yeah,
Okay, yeah,
yeah.
that makes sense. Okay, I'll start with like a challenging one. I think he doesn't have any policies.
Okay, I wish. That sounds like the best president
Border
ever.
policy.
You think he has no?
He
Really?
has a border policy, right?
I
And
think he
he
has.
has a he stated
No, he
he
doesn't.
stated his position that he will try to end the Ukraine-Russia war as soon as
But
possible.
those are ideas. They're not policies. That's the problem. Nobody
Ideas
cares about policies.
ideas translate into policy, right?
Yeah, but if he doesn't translate them into policy, then it's utterly useless. Like he had 4 years to build his policies. He never built. He still doesn't. He still has concepts of a plan of what he's going to do with Medicare. He wants to change
That was
Obamacare
such
with
a
something.
funny quote. Like,
You
you
can
have a
Yeah,
you can
plan? I have
judge him.
concepts of a plan.
and it's not only with Medicare. He also has concepts of a plan in ending the war. He doesn't want to tell us how he's going to end it. He's just going to miraculously end it. He's probably going to end it, to be honest, because
You
He
can
he's just
hasn't
going to.
you
really
can
told
judge
us
him.
how he's going to
You
end
can
it, and
judge
that's
him
kind
about
of
it.
annoying.
You can judge him about it.
Oh
Say
no,
after 1 or 2 years. Right? He has just come. He hasn't even come to office.
no,
So
but
how
that's the
can we
problem.
judge him about it after
We
1 year?
shouldn't have to expect something without him stating his policies. That's why we should vote people based
I
on
would like to
policies.
know more about his policy positions because he
Yeah.
doesn't have very concrete ones
What
that
if he
he's addressed
tells you
public
he's gonna
recently.
do something and he says I'm gonna deport every illegal immigrant and then he uses all national debt, $3 billion to do it. He's
He
gonna do
does
it, but
say
he's
that he
gonna.
wants to deport all the illegal immigrants. That's a policy position he has.
Yeah, I mean, but that's not a policy either, because like
Well, how in depth
policies
he
are.
goes with it is the problem. He doesn't really try to
Yeah.
elaborate. Besides that, he
But
just
that's the
has a
thing.
goal.
It's he just made it. He made politics all about feelings and all about vibes. It's not about policy anymore. Like there's no policy for Trump. So that's probably my first.
I I am
Thing.
from India, so I will make a point. I am from India. I
Sure.
don't know much about the policy and all these things, how they go about in US. But I remember listening to a news item in which it is stated was that I don't know what specific law your Congress was passing, but you have a Congress, right? So
Yeah, we do.
Congress was passing a certain law, and it was a 3,000 page document. And I don't remember, it was something like 100 billion or something of that round of figure was passed off in that 3,000 page document. And I don't think like the it's and it had some few important policy positions in the beginning, but those 3,000 pages I think did contain many of policies that I think you or any most of the common people of USA would not have any idea about, and your Congress people would have just passed them as to enable their own certain agendas. And that's why I think if you are that serious about policy, I think first of all you should demand your Congress to pass one law at a time. If policy is that serious for you, then it will make sense. Or else you can just the subprime crisis, right? In subprime crisis, what happened? Your bad prime some stocks were combined with good stocks, right? and it led to the downfall of whole stock market in 2008.
Wait,
Something like that
can
can
I?
happen in terms of
But
laws also.
I think you have it
Wait one
flawed a
second.
little bit because
Wait one
Congress
second.
can pass laws and bills. Yep.
Wait one
Okay.
second. Okay, so I'm sorry to interrupt. So Mr. Stewie, I'm not getting. I had to do something, so I didn't. I let you speak, everybody, but I didn't understand your main contention. So you're unhappy with Trump because he doesn't have a policy.
He doesn't have any policies. Yes.
Why is
So he
that?
doesn't.
Wait, hold
So
on.
what I would say, he doesn't have a
Wait,
good plan for
wait,
how he's going to run the country. Yep.
wait one second. So how is it now? Convince me that that's a bad thing.
So if somebody doesn't have a plan on how he's going to run the country, puts people. There is no good reason why anybody should vote for somebody who doesn't know how he's going to implement the things he want to do. You can tell people, you can give people the moon. You can tell them, hey, I'm going to make you guys all rich. Everybody's going to have a car. Everybody's going to have a house. But that's not realistic. We live in reality, and politics is about reality. So you're going to have to look at policies and
Wait,
look how they're going to implement it
wait,
into the system.
wait one
Yeah.
second. One second. So, right, you're trying to convince me not to vote for Trump, right? Basically, right? That's what.
At this point, it doesn't really. At this point, I can't really do anything because you already won.
Right.
It's
I'm just
true.
saying why I didn't vote
There's
for him.
honestly not really any meaningful reason to talk about like Trump being bad in relation to this, because he's going to have the power. You would just have to focus on the next politician that would be elected, because this would be the final term that he's allowed to.
We don't know that.
Well, we'll see about that.
I mean, you got to pay attention to his legacy and like the people that he chose as his
Nah.
picks, because those are the most likely successors.
Wait one
like
second.
Well, yeah,
Vivek,
that's what
JD
I mean. You
Vance,
focus on all
Tulsi
the people
Gabbard.
that,
Wait,
that are
The
likely to
whole
be
fucking Nazi
wait one
team.
second. Wait
You
one
can
second.
like complain about the party.
Wait. Hold on, Mr. Stewie. I'm still confused. So, right, but
What's
at the
up?
end of the day, we're having a discussion because you're trying to convince me that it's not a good idea to support Trump, right?
Well, to be honest, our first conversation was why I'm a never Trumper. It's
Mhm.
because I don't see any policies. But if you want me to convince you, well, that's a different discussion. I can't. I don't know how I could convince you. I don't know what your values are. I don't know what you want in a president, right? But I'm just saying what my values are. I value a person who is actually critically
Fine.
showing his work and showing
Fine.
what he's going to do for the American people.
Okay. So I asked you, why are you a never Trumper? And you said, well, because Trump doesn't have a policy. And I said, okay, why is not having a policy a bad thing?
He does have a policy.
No. Well, hold on. Wait. No.
It's like
I agree.
it's
I
a complete.
agree. I agree that he obviously has policies, but let's assume he doesn't. I mean, either way, I don't understand why that's an issue. Like, you could say, I mean, it's like for a
You
never.
don't.
Wait one
It's a.
second. Wait. For somebody to say I'm a never Trump. Wait one second. For somebody to say I'm a never Trumper, and I ask why, and your first thing that comes to mind is he has no policy, and I'm like, let's assume he
Yep.
doesn't. Wait one second. Let's assume he doesn't. That's why you're a never Trump. You're a never Trumper because a guy doesn't have a policy. That's
Yeah, I would say that's a pretty big deal, dude.
no.
Yeah, I thought.
Okay.
What?
I think it's a big deal if you're the president and you don't have a policy.
Dude, it's like going
Okay.
to a job interview, like as a judge, and then coming dressed as a trash bag and saying, "Hey, what up, dude? I'm here for the job." Like, it's not a serious thing to
Okay.
ask me, dude.
I
Like,
understand.
you need
I
standards
understand.
for a president
I
in the
understand.
The
highest,
president is basically
Wait.
giving the
most
entire
powerful
U.S.
person in the
his
world.
resume.
Anyway,
Us, the voters, need to look at his resume and say, yeah, I want to vote for this.
exactly. So I vote for Trump exactly based on a resume, and I don't care if he has or doesn't have a policy. I honestly, I don't see how why
But
you.
that's part of his resume, right? Like you can listen. This is what I mean. Like you can
Mhm.
lie and lie all over again, right? Like as he has done, he's a pathological liar, right?
No,
But
we're
he
not.
can literally give
We're
you
not
the
talking. No,
okay,
no. But
sure, sure.
you're
Hold
adding.
on, but let me just finish. He can say whatever he
No,
wants,
but you're
but
adding.
how he's gonna implement it is the problem, right? Like we have to live in reality. We can't just go off of
Look,
what he's
I asked
saying.
you. Look, Stewie, I asked you why are you never Trumper, and I would expect something, meaningful. But what you're giving
Oh,
me,
there's more stuff, but I
no.
think the first thing I mentioned is already meaningful enough. Yeah.
So I told you. That's why I responded. I said, okay, you're trying to change my mind, right? Let's say we were having this conversation just before the election, and you're trying to change my mind, and that is how. Why would you expect this to change anyone's mind?
I wouldn't try to change your mind. That's the problem. I thought you were asking me why I'm a never Trumper. I don't
That's the,
believe I can change people's minds because I don't know what your values are. I don't know you well enough to know what you value
I
and
understand.
why you
But that's what I
what are
mean.
your
But
concerns.
that's what I mean. I mean, like you're trying to tell me why are you a never Trumper, and it's based on, well, because Trump doesn't have a policy. I'm like, so what?
Yeah, my
I don't
values
see
are that
I don't see I
somebody
don't
should be
see
qualified.
I don't see how I don't see how that should impact a person.
You don't see how that
I don't know.
doesn't
I
make you
don't. I don't
qualified to
know.
We're not
Personally,
talking about like your mother, your father, your uncle, or like some guy that you're associated with. We're talking about the president. He needs to have a policy.
no.
yeah.
I don't think you need, like, when I
Okay.
select,
Well, then we
like,
just disagree. I think it's just
so if I
very
see
simple then.
if I see if I know one person, for me, one person is a capitalist,
I remember that.
and the other one is a
Sorry,
commun.
I was laughing at something else.
Bro, it's just not that simple.
1 second, Adeptus. If I see one person, if I have two, what do you call, political,
Hmm.
whatever that they're running, two running people,
Uh-huh.
candidates, two candidates. One is a known capitalist, and one is a communist. I don't care what the policy is. Once you tell me one is a capitalist and one is a communist, I don't need to hear anything else. I know enough. I know I'm voting for the capitalist. I would never vote for a communist.
Bro, you're not making
That's
our side sound like
that's
intelligent, man.
fine, but you do have to understand that you're making your decision based off one one thing.
No, I'm saying
You
I mean,
I
you're
know. I
saying
look.
you're impulsive.
I look.
You hear
I look
you
at a
hear
person.
communist and you say I'm not going to vote for that person because someone said that they're communist. That's not very like intellectual, especially since we're talking about American candidates. Like no one's a communist here.
Look,
Everyone's a capitalist by
the
default.
point is that he's a never Trumper, and the motivation for his never Trumpness, to me, is nothing. Is zero. There's
that's
no.
why I told you. Like I can't convince you because maybe you have different values than me. I'm not trying to convince you because I don't think I can. I can't convince everybody
Okay.
All right.
because I would have to convince you
Let's
to
talk
change your
about.
values and that's just
Let's talk
not always
about.
possible,
It's
right?
fine. Let's talk about quantum entanglement. Does anybody know anything about quantum entanglement?
Oh man.
Quantum
Oh, why is it
entanglement.
bullshit? Yeah, I also wanted to ask
Can you
reason for
explain like
suspecting it.
I don't know
You
can
anything
you
about
you
that.
can
elaborate?
you can watch the video. So I posted a video in the side chat. Um, there's a video, you can watch it. It's from a famous YouTube channel, Fermilab, by Dr. Don Lincoln, and he says this is the weirdest thing in physics. Then he explains that if you
Oh, you're
create,
talking about physics.
yeah, quantum
Ugh,
physics, quantum
mm,
entanglement.
you like physics?
I love physics, of course. I love everything.
Ugh,
I love every form of human knowledge.
yeah, I don't know about physics. quantum mechanics and nah.
Are you
Not my thing.
gay?
Only on Sundays. Yeah. No, I'm not.
No.
I'm as straight as a pole. Actually, no,
How
not
could you not
completely.
like physics?
I don't know, dude. It's just
Are
boring.
you
I mean,
religious?
I
Do you
might.
believe in Jesus?
Nope. I'm an atheist.
Then you don't love science?
Nah, I'm good. I mean, I like basic science. I don't need to know every intricate part of the fucking.
Are
No,
you
I'm good. Like,
16?
no, I'm 20.
I don't know. I don't get it. Like,
Everybody has different interests. I think y'all like that. That's
would
one
you
thing
say
you same.
do you love math? Are you good at math?
No, I'm very bad at math.
Are you studying economics?
What?
Hmm?
Are you studying economics?
Probably
If I'm
not.
studying economics or him?
Yes.
Economics
Yes.
No,
is
I'm not.
there's a lot of math. You got to be good at math to study economics.
No, I made that comment because he talked a lot about policies. So I thought that he would have like generally people who are from economics background or something are that much interested in the nitty-gritties and mathematical aspects of and results of policy positions. So that's why I asked.
No,
Bulbasaur, you
I
got to
just
fix
think
your audio. I can barely hear what you're saying. You're like whispering.
no. He was saying typically people who are in economics like about policy and talk, but nah, I just think that's like the most important thing you should go to look at people's policies. I don't if you want to know
Anyway,
like how.
so I don't get it. What's going on with quantum entanglement? It's like all the physicists believe that quantum entanglement exists, and I watched this video and it makes no sense. Like I don't know what's going on. So I need someone to help me understand this video.
I don't think you're gonna find him here, bro,
Where
because
where
we're all
where would I
clueless
find them?
souls.
Even I don't know.
I don't know, dude.
Simplistically what I understand is about quantum. You know about atoms, right?
What do I know?
Mr. Slave, you know about atoms? There is something called atom,
Yeah,
ATOM,
yeah,
atoms.
yeah,
Atoms are made up of subatomic particles.
yeah.
These subatomic particles like electron, proton, neutron,
No,
and
no,
etc.
that's not. I know, but that's not what this issue is about. This issue is about, yeah, when you test little particles like electrons, when you test those
Yeah, they are called
particles,
subatomic particles.
yeah, so when you test them for like it's a very intricate, very specific test. When you test
Fuck
entanglement,
me, dude.
I
Ugh.
I
Why are
am
you guys
telling
even talking
you,
about this?
I am telling you a simplistic, like I'm not physics guy. I studied a bit of biology, but I had some interest in general science. So that's why I
I
watched
understand.
a few videos and I'm telling you, yeah, then it would be same as you do.
The only thing
But
I
I,
know about quantum mechanics is and that dummy stuff. I think at least I'm like a whole dummy on it, but like you can't touch anything, right?
What
Like
is demi?
on the a dummy.
Demisexual.
What
Like
is
you
Nice.
can't
demi?
touch anything. You can't touch anything on a quantum physics level or
What
something,
is
right? Like on
demi?
a.
It's like,
I said dummy, bro.
Oh,
Damn, you're
dummy.
stuck
Oh,
on one
okay.
thing. Yeah,
no,
I
he's
was
got you
saying
there. You
you
dummy.
can't
Slave,
touch something.
I will just make one
I just
empirical
heard
comment.
you can't touch something on the quantum physics
Oh,
level, right? Like, is that true?
I
Physically,
mean,
yes, I can.
you're made up out of quantum particles, so
Yeah,
you're touching
you
them.
can't touch anything.
I mean, you're it. You are made up of little tiny particles. So what do you I don't know what it would mean to touch what you're
Mr.
made
Slave,
out
I,
of.
I will just make one empirical comment. As far
Yeah.
as I
Yeah.
have heard,
Um.
quantum computers are using this quantum entanglement to
So,
Yeah.
what do you guys
make
think about like the political and economic state of the world right
just
now? Like,
just
No,
let me
uh,
just let me finish my comment.
ew.
Are using quantum entanglement to make their computation. So when I think in the news in the regular
God,
media,
help me.
uh, the comments about its results making impact will come out, then I will believe that yeah, quantum entanglement is something useful. Till
Okay.
It's
then,
like
yeah,
they're
I am
shitting in
hesitant.
my
Wait,
ear.
Stewie, you don't have to stay. Come on, stop. We had a political discuss. Oh, he left. Okay. So, Mr. Balbazour, yeah. So I think quantum computers don't exist because I think quantum entanglement is BS. So quantum computers are BS. The whole field is complete BS. It doesn't make any sense. It's nonsensical. I cannot make any
There,
sense out of this field.
I will make a few points. First, I don't know enough about the field for me to make a concrete comment that the whole field is bullshit or it is highly like result giving or good field. Second comment that right now with whatever you or I as a common person think will not matter because those companies whatever technology they have developed, they have called it something called quantum computing, and they are using and they are investing their billions of dollars in it, and whatever you or me say sitting here in Discord will not impact their, I would say, 5 or 10 years plan for investments in quantum computing
How do you
technology.
know?
Oh,
Third thing,
How do you
that
know?
will they like will Google change its quantum computing investment based
oh
on
my
what you will think?
Yeah. How do you know that it will not?
If it will, then that would be great. Please change those policies and make them invest in something like I don't know, nuclear energy. Yeah, that is a good place where money
I
is
think
going
they're
to
actually investing
use.
in that. They just started investing in nuclear energy.
Yeah, but it is still like much behind. Like I believe that nuclear energy should be much more hyped than solar and wind and all these things, but I see nuclear's hype a bit less compared to these in terms of having a sustainable source of energy which will be how do this climate activists say, carbon free source of energy. Nuclear is the best among all
Of
in
course.
terms of a stable, but yeah, these policy makers, as the guys Stewie was talking about, I don't know what they have eaten, but they don't care about these things. They talk about
Anyway,
solar,
it
when
doesn't matter.
even now
Look,
private companies are investing.
okay, I mean, but the point is, I need someone to explain to me what's going on with quantum entanglement because I'm not following this video. Nothing in this video makes any sense.
Do you have a good grasp of physics, like mathematical? Are you involved in the field,
I don't
or
think
are you
that's.
a generalist as me?
I don't think that's the problem. I mean, it's a simple video for laymen. It's not a video for like you don't. There's no math in this video.
Maybe you can go to Chat GPT and ask it to explain quantum
ChatGPT
entanglement.
ChatGPT is brainwashed. ChatGPT believes exactly what the mainstream physicists talk about. ChatGPT just regurgitates what it reads on the internet. And
True. I
and
accept your claim, but the thing is, I will counter it with my own claim that, like, I, as a general person, as a lay person, like, I also don't have in-depth knowledge of physics.
there's
Now,
no
if I am willing,
you don't for this video you don't need any in-depth knowledge. He explains everything. Everything is very simple, but nothing makes
mm,
sense. It's like it, I can explain this video to my grandmother, but but she would be just as perplexed as I am. She would say, "Okay, I don't understand why he says that." I mean, or maybe she'll be able to
which part,
the whole
which part is
video. I
making
mean,
you
it's
feel?
I mean, you have to watch the video and then basically explain to me that I just posted the graph from the end of the video. You have to explain to me how this graph does not contradict everything he talked about in the first half. This graph is a complete contradiction to the first part of the video. In the first part of the video, he says when we measure one particle, then we always measure the other particle in the opposite direction. But this graph doesn't say that. This graph says that there is some distribution, but wait, let me think about it.
Wait. Measurement direction is in degrees, I believe, right?
Let me think. Yeah, this is in degrees.
So as you can see, the plot is peaking at 180 degrees. 180 degree means opposite to each other. Percentage in that direction. So at 180 degrees, measurement direction at 180 degree, the percentage in that direction is 100. I can make this comment based on this graph. I don't know anything about physics. I'm just making a comment on this graph. You get me?
That what?
So in this graph, as you can, if you make the graph larger, on x-axis you have 0, 90 degree, 180 degree, 270, and 360 degrees, right? In a circle you have 360 degree. When you go around the circle, you are at 0, that is 360 degree. What is the meaning of 180 degree?
Okay, I think I understand. Okay, so when one is up, the other is definitely down. But if you don't measure exactly down, then you get a distribution. Okay.
Yes. So I think that is the thing, that if particles are quantum entangled, then they will if one is directed in one direction, then another will definitely be directed in another direction. And based on I think there is a level of
But
quantum entanglement also.
why do you need to say? He claims that the only way they can be correlated is because of transfer of information. They need to transfer information between them.
I think here they are saying that this is a transfer of information because of the fact that in all cases where there is quantum entanglement, they are seeing this one being in this opposite polarity. You understand polarity, right? One in
Yeah.
one direction, another in another direction. So, or opposite vectors, whatever you want to say. Now, I think they are saying that this 100% linkage makes it a fact of transfer of information. If there was not this kind of 100% linkage, because you are not looking at both particles, you are just looking at one particle, and you can know information about the other particle
No,
just by looking at.
he's saying that the straight lines are hidden variables and the red line is quantum mechanics. Can you explain to me the blue and the red?
For this part, I would have to see the video to know what is a
So
hidden
actually
variable and
that he
what is.
doesn't explain in the video. He just asserts it. He just says that is the difference. He doesn't explain why. Let me hear it again.
Yeah, you can do that, or what you can do is you can
Give me
if you
a
are
minute.
really interested in.
Give me a minute. I'm gonna go listen to it again.
Sure.
1 second.
Go ahead.
The second measurement will be in the direction the second arrow is pointing. If the second arrow is pointing upward, we know that the second measurement is always downward. So that means the second measurement agrees 0% of the time. If the second arrow is pointing at 90 degrees to the right, the second measurement can be right or left with equal probability. So it will be to the right only 50% of the time. If the second arrow is pointing downward, we know that the second measurement always is downward. So it is in that direction 100% of the time. And as we go to 360 degrees, the pattern is reversed. It's very important that we see that the predictions from hidden variables in quantum mechanics are different. This is key. So those are predictions. What does a measurement say? Well, these black dots show the measurement, and they are quite definitive. Quantum mechanics.
But I don't understand. Well, who's? Why is this the blue and this the red? I don't get it.
Is correct, and the whole idea of hidden variables is completely ruled out. So what does this mean? It means that the idea that the final measurement is already determined at the moment the two particles is entangled is false. It means that when you measure one of the two particles, the quantum information is transferred to the other particle at a speed faster than light.
But you already said that in the first half. You already said that in the first half. I'm so confused.
Mechanics or whatever.
Anyway, I just listened to it again, and
Oh my god!
I'm so confused because, I mean, he said like
Oh
he
my
spends.
god!
Look, did he leave?
Why
Okay.
were you confused?
So I'm confused. I'm so confused for many reasons. One of the reasons is that he spends the second half of the video explaining the final graph, and the first half of the video explaining just normal entanglement. And he doesn't anyway. He doesn't explain the graph, and he says this graph means that the two particles are communicating, violating relativity. But he already said that in the first half. The first half of the video already says that the particles are communicating beyond instantaneously across the universe. That's the first half. And then he spends the second half restating it as if he already proved it in the first half. So I don't get it.
No.
What?
In first half, did he give any experimental evidence? I think I haven't seen the video. Maybe it is possible that in first half
Yes,
he
there
was
is
making
experimental evidence. Yes, I mean, he shows experimental evidence.
Okay. So, or maybe what he's doing is he is giving you two lines of different experimental evidence. Like in science, usually, as it is the case, that you try to prove a certain theory with multiple, through different kinds of experiments, which might be related to different domains, and that leads you to a more concrete understanding, or to a more concrete you will be able to say that this theory is true, or say here quantum entanglement is true in a more concrete manner if you are able to prove it through multiple lines of evidence or something like that. Maybe that is the case. And as I told you, like for me also, quantum entanglement is a unknown territory in terms of its math and in terms of
No,
its
there's no math. There's no math. There's no math in
there.
this. This video is very simple, but I don't.
Yeah, this
Hold on, hold on,
this video is
hold on,
this video is really
hold,
simple.
hold,
Yeah.
hold on. This video is very simple, so there's no math in this video at all.
Let me check the video. Let me also see the
Yeah,
video.
go watch it, come back, and we can talk about it. Okay, I'll be right back.
What are you guys talking about? I'm so confused. I don't know what's going on in there.
Amber, can you talk?
He's got his mic muted. His mic's muted.
I know, I know.
Yeah.
But
What's you? Where are you from, by the way? You got an accent, haven't you?
yeah, I'm from New York.
All right, nice. Do you like hot dogs?
No, I hate hot dogs.
Come on now, come on now.
Hate them. No, I like steak.
Huh?
Steak. I like steak and eggs.
Steak and eggs, yeah.
Yeah, steak and eggs is awesome.
I like steak. I like eggs, but I've never had them together.
Yeah,
Yeah.
in Brazil, they serve every like steak and eggs, cheeseburger and eggs. It's like everything goes with eggs. In in the US we have like stuff with French fries. Like a normal side dish is French fries or mashed potatoes or a salad. In Brazil, the side dish is basically always eggs.
Do you have the egg on top?
In a cheeseburger, yeah, it's on top. With the steak, it's on the side.
See, I would have had it. I've seen in my head, I would have had the steak on the bottom, then maybe an egg on top, and then maybe a bit of salt, and then
But
that's the
if
way
you
I
go to
would have made it.
Brazil, the steaks are very cheap and super high quality. It's like you're eating the most delicious. The ribeyes, the most expensive ribeyes, are basically like a cheeseburger. It's the same. It's basically the same cost. It's super cheap. And every apartment has a built-in barbecue.
Well, so what is it just for outdoor cooking kind of thing?
But it's indoor. It's inside the house, but there's a chimney installed in every apartment. Some of them it's external, but there's no such thing as an apartment with no barbecue, with a real chimney. So you can
Interesting,
actually,
isn't it?
yeah, you can barbecue inside your house, no problem.
I wonder what is. It's just got to be a culture thing, then, isn't it?
I guess.
Yeah.
And everywhere you go, anyway, the steaks are unbelievable. It's like you can eat so
Is
much.
that where you come from then? Are you Brazilian?
I travel. I'm all over the place. I've been basically to every corner of the planet.
Oh, yeah, cool, man.
Yeah.
Do you know in Germany, if you get an apartment, it don't come with a kitchen usually. You
No.
have to install your own kitchen. Yeah, look it up. You have to install your own kitchen.
Oh, I don't know.
Yeah.
Technically, the planet doesn't. Whatever, you can't continue.
Look it up. That's crazy. I thought the same thing. I was like, "There's no fucking way."
No,
But yeah,
I
you have
didn't.
to install your own cupboards and your fridges and everything. Not coming often. Even if you're renting, if you're just renting, you got to get your own kitchen. Crazy.
Anyway, did you guys hear what happened in Amsterdam with the Jews and the Muslims?
Yeah.
What's going on over there? Does anybody know?
I don't know. I've no idea. But
I
usually
haven't.
Jews and
I
Muslims,
saw
I
like
can
an
almost
article
assume.
about it, but I never read it.
So
Let me guess, something bad's happened because those two don't get along, do they? The Jews and the Muslims.
No, usually they get along, except maybe like in Israel they have wars, but
Well-
nowhere else. And now there was like a big thing happened in Amsterdam or somewhere.
I'll tell you my isolated perspective, yeah. Just what I've heard online and those around me. Muslims have not got very nice things to say about Jews, and Jews haven't got so many nice things to say about Muslims, yeah. And it might just because at current times, but you know what I mean.
Yeah. Anyway, I don't know what to do with this quantum entanglement. So he says, so 1 points up.
Quantum entanglement is not bullshit. It's
All
the
right.
most brilliant thing ever invented.
Okay. That sounds like pretty cultish.
The
So
reason why they're different is because it has different experimental outcomes. If they were the
Yes.
same, then there would be the same experimental outcome. The
Yes.
fact that the graphs are different demonstrate that it's different.
Yeah, entanglement.
if you could please watch the video that I posted in the side chat and explain to me.
I did watch it.
What?
I watched the video.
So I posted a graph at the end of the in the side chat. I posted the graph from the end of the video. So he says the blue line is the expectation according to hidden variables. And the red line is the
Yes.
expectation based on quantum mechanics. Could you explain to me? So he doesn't explain the blue line. So he says the blue
He did
line.
explain the blue line.
Okay.
He explained hidden variables earlier in the video.
Okay. So
The baseballs and the boxes. That's what hidden variables are.
okay. So you're saying the red line is based on the assumption that the two particles are communicating, right? I mean the red line is the
Sort
red
of.
line. The red line and the black dots are supposed to be the spooky action at a distance. The two particles are communicating telepathically or something, right? I mean, spooky means like telepathy or something.
I mean, I guess, yeah.
So you're telling me that the red line is if we expect the particles to be communicating in a spooky way telepathically, and the blue line is if you expect them to not communicate.
Yes.
All right. And so I don't get it. I mean,
It's very unintuitive.
why?
That's for sure.
What do you mean it's unintuitive? Why would you say that it's the blue line, the blue straight lines is that's hidden variables? I mean, why is that? Could you show me?
Well, because it behaves similarly to hidden variables.
No,
So
no,
if you measure it, it would experience the same outcomes as hidden variables if it was hidden variables. But
no.
the experimental outcomes are different, and that's how you know it's not hidden variables.
No, I'm lost. 1 second. So, can you derive the blue lines? Can you explain to me how he derived? Right, show me the derivation of the blue lines versus the red line. Could you? He didn't do that, right?
Wait, what? Say it again?
Can you? He didn't derive the blue nor the red line. He didn't show why he expects the red nor the blue line. He didn't derive the equation or the logic. He didn't derive it. He just said, "This is what we expect." The according to hidden
Well,
variables.
yeah, because this is a very layman's video. If you want a video to go into like the in-depth mathematical like stuff with it, you need to watch a video that goes into the math. Of course, you wouldn't expect the answer from a video that doesn't show you that answer. Like you would just need to find another video that explains it differently.
I
Like I
recognize.
wouldn't watch like a single video on like
I
any
recognize.
subject to feel like I grasp the whole like subject.
I recognize your voice. Have we ever spoken before?
I believe I've been in conversations before, either where like you and I were disagreeing or we were talking with other groups of people.
Oh, you're a furry?
It depends on your definition of furry. How would you define a furry?
I don't judge. I don't care. Like
No,
you,
I know, but it depends on your definition of furry. Because like
I don't
I
know.
would
I
say
don't know.
my own individual definition of
I
furry, I'm furry.
like I have my fetishes, but I when I see people who are furry, like it doesn't mean anything to me. It's like it doesn't excite me sexually, and I
Well, like it
understand.
doesn't do that either for me.
Okay, I
Like being a furry isn't necessarily a sexual like thing.
then what is it? Then I don't
It's
understand.
just about identifying with it.
Okay, why would you want to identify as a furry? Why? Like everything else you say, you're
So like
here. Let me go through the list.
it's about
No, 1 second. Let's go through the list. So you say you're an atheist. Yeah, I'm an atheist. You're democratic socialist. I'm a capitalist. Fine. You're a moral relativist. I'm a moral relativist. United States, me too. Male, me too. Feminist, I guess. Gamer, I'm not. Pro-choice, I am. But furry, why would you identify as a furry? I'm trying to understand. Like, no, I'm not even trying to understand. I'm just like, to me, it doesn't mean anything. You might as well tell me that you have, I don't know, you have something special about you, and you belong to that group that are people. Like, you might as well tell me you have two middle names, or that you
Well, some people do have two middle names.
I know,
That is true.
but that is completely like, the most I don't care. My response is the most I don't care that you can imagine. That's how I
Well,
feel
yeah.
about.
So,
That's how
like,
I.
if you don't care, then I can just continue being me, and then you can
Of
continue being
course,
you, and then
of
we can move
course,
on with our
of
lives.
no, of course. No, I'm just that I'm being the least judgmental, because I know some
Well, I'm
people.
not saying you're being judgmental.
No, because I know some people really judge furries to be something bad, quote unquote. Like,
Oh yeah,
like they used
there are
to
people like that.
like they used to judge gay people as bad, and some people still judge gay people as bad. So today
Yeah.
they judge, like, we didn't used to have furries in the old days. We only had gays, and it was illegal to be gay. And then they made it legal to be gay, and now there is more stuff. Now people have there's more variety. Like, we used to think, oh, there's only straight and gay, and then once we allowed gay, I'm not being 100% facetious. I'm like, but I'm pretending to be like a normie, the way a normie would speak. So a normie would say, we used to gayness used to be illegal, and we forced them into the closet. But once we allowed them to leave the closet, we thought that would be it. But instead, now there's like a rain of all these weirdos, quote unquote. I'm just pretending to be a normie. Obviously, I'm not a normie. I don't care for normies, but that's that's what I'm saying. I'm saying, like, normies judge you. That's all I'm saying.
Right.
That's all I'm saying. Normies, like, society, quote unquote, judges you. That's all I'm
Right.
saying. So that I don't judge you. I'm just saying other people judge you, and they can go F themselves. I honestly don't care about their existence. Anyone who judges anyone can go jump in the lake. Like, I don't care. I don't care for you if you judge.
Right.
If you're judgmental,
I was never saying that you were judging me or anything.
right.
You don't need to like say that you're not judging me
No,
because I
but
didn't think you were.
like, to me, like, I'm so neutral about furry. Like, if you told me that you are into BDSM, I would say, "Oh, awesome! So we're the same." Like, I'm into like, no one identifies as BDSM. That's the weirdest thing. It's like no one identifies they're into incest. No one identifies into that they're into any other fetish. No one.
Right, but again, furry isn't a fetish.
What do you mean it's not a fetish? Of course it's what do you mean it's not a fetish? It's not a
No, okay,
fetish?
so there's furry in the sense there are people who have a fetish for it, right? But it is not in and of itself a fetish.
Wait a minute. Wait a minute. Are you telling me that some people are furry not sexually?
Yeah.
So why are they ashamed? So what's the shame? Why is the
I
shame?
don't think they're ashamed. I wouldn't say that they're ashamed. I would say that society shames them due to a misconception about like the things they find
Wait a
interesting.
minute. There
It would
was
be like if I found Pac-Man cool
wait.
and they're like, that's a
Listen, listen.
fetish.
hold on. So there was once a congressman or a senator that he was outed as a furry, and the same day he resigned. Do you remember that?
No, it doesn't sound familiar, but if it happened, then bummer.
Like, if you would be outed as gay, you wouldn't resign. Unless you're. Even there was this one Republican who was having sex in public bathrooms in airports. There's like a famous story, and he was outed because he was caught. Apparently, it's illegal to have sex in public bathrooms in airports. Anyway, so he was outed. He was fined, and he paid the fine or something. And then he didn't resign. And I don't remember if he still serves or whatever. So even those guys like are not embarrassed as much as furries. It's like,
Well, yeah, but it's mostly due to a misconception placed upon people, and they find an embarrassment because they don't want to be associated with something that isn't necessarily part of themselves. And also, there are necessarily negative social repercussions due to that association.
anyway. But no one identifies as gay on Discord, right? Do they? They identify as wait, they identify as LGBT. You're not LGBT, are you?
I'm bi,
Why don't you?
so I would fall into that. Yeah.
So why don't you post your LGBT?
Because I don't necessarily consider it like a part of like my necessary like identity in that sense.
Hmm.
Like I am what I am, but like I don't consider it to be something important.
I see.
Some
Okay.
people do, some people don't.
Wait, are you more like
Like I don't walk around like broadcasting that I'm a dude.
No,
It's
you
like
say,
I don't consider that important.
no, you
You
say
know?
male. You identify blue male. Look, I'm not
Yeah.
judging you. I'm not judging you. I don't care. I mean, you.
Like if you're talking about like all the things there, I just clicked on what like came to me.
Okay.
Like what was on the list. I'm like, sure, you know?
Sure.
Like it wasn't really something I thought about.
That's fine. That's cool. Anyway, back to entanglement. So so he says, Don Lincoln, he says in the last image, if you pull it up that I posted, so the blue,
Yes.
so the blue is the predicted based on hidden variables, and the red is based on the information, the telepathy. So you're telling me the difference between telepathy and hidden variables? I mean, it looks like, I mean, if you take the hidden variables and you just take the cosine of that, you probably get the same graph, or cosine squared.
But like why would you do the cosine squared?
But that's not important because I don't need to do information telepathy. The question is, do you need telepathy or do you not need telepathy? Right? If I can reproduce the red line without telepathy, then that disproves the telepathy. It doesn't disprove, but if you don't need telepathy between particles, then we're done. So all I'm saying is, if I can cosine squared the blue line and get the red line, then we don't need telepathy. Then quantum entanglement spooky action is gone. And I don't even think.
Well, if you would
Mhm.
really want to get into it, you would want to watch not just a surface level like layman explanation.
I watched.
Because it's not intuitive
I
at all.
watched. So I watched literally every video on YouTube about this many times. I've written many papers. I've written 3 papers about this. I've had this
About
discussion.
quantum mechanics?
Quantum entanglement. Yeah, let me post the
Just
paper.
entanglement specifically, not just quantum mechanics.
Yeah, here I'll show you the papers that I've written. I've written Python scripts that reproduce these graphs without assuming information leaking from particle 1 to 2.
But
So,
is that
mhm.
the same math as is used in quantum mechanics? Because
the
quantum entanglement is still part of quantum mechanics as
the whole
a field
point
of study.
the whole point is I can reproduce the graph without telepathy.
But does it have explanatory power?
I reproduce the graph. What do you want me to do?
You reproduce the graph, but with the same math?
I do it. I use a Python script. I do cosine. I just cosine squared a hidden
Right, but
variable.
is the mathematical equation that gives the outcome for the quantum like entanglement the same as the one you input on the computer?
What? Why does it
Does the
matter?
Python do the same math?
Same as what?
If the math is different,
Same as
then the
what?
experimental outcome is different.
Same as what?
The same math.
Same as what?
Get the outcome.
Same
As quantum mechanics.
Anyway, I don't do. I looked at this graph and I reproduced the graph, the red line. I reproduced the black dots, the black squares, meaning I can give you the prediction of the experiment with a hidden variable. Here, let me show you the code. I'll show you the paper. Ready papers. Software simulation. There's 2 papers, but three codes. So share, copy. Are you still here?
Yes, I'm still here.
Paper 1. It has a link to the code, and it's a short paper, and there's a graph inside.
Did you just like write this paper? Is it published anywhere? Has it been accredited by anyone who's like an expert in the field?
I mean, many people. I've shown it to many people.
Yo, I'm back, peeps.
Resolve.
Y'all miss me?
We're talking about quantum entanglement.
Like what? Like what?
Mm-hmm. 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 Okay. Stop making noise. Stop. Are you looking at it?
I am looking and trying my best to understand the paper. I also have dyslexia, so it's difficult.
Okay. I mean, sure. I mean, yeah, you can try and read it and understand it, and then I'll explain it to you.
But you could just try to explain it to me.
Okay, then let me. I'm just throwing out some trash from all my papers. Mm-hmm. Do you know? Can you read Python script?
No, I don't know a thing about programming.
Dyslexia is usually it comes with very high IQ.
Oh, I just took an IQ test today. My IQ on the test says it's like 123.
Yeah, you're a genius, so you'll be able to.
No, but quantum entanglement, what is that? What is quantum?
Very complicated stuff that seems to not be very intuitive.
I wouldn't say it's
Oh,
complicated. I would say
okay.
it's just it's supposed to be anti-intuitive. I don't find it anti-intuitive at all.
Well, you don't
Oh,
seem to quite understand it.
oh, yeah.
That's where I would argue it's not intuitive because you're not really understanding it.
Well,
Oh, yeah.
here is I wrote code. Here's an image in the I just posted it in SciChat. So this is the image that
Can I take a look at the image or no? Can
yeah,
I take a look of it?
it's in the
Do you allow
SciChat.
me to?
It's in the SciChat.
You allow me to? Yeah, but I need your permission first.
I'm gonna mute you if you're gonna be interruptive.
Sorry, I just needed your permission.
You don't. So Sammy, if you look at my at the image in the SciChat, so I created this from what they call hidden variables. That is what my hidden variables look like. Now, if you want, we can discuss the code.
Yeah. What you say though? How I figure it out?
Okay. Have you also like
Mhm.
I wouldn't just have your like simulated quantum entanglement graph. I would also have that simulated quantum entanglement with the expected outcome if it's just a hidden variable, like he has in the video.
Give me a minute. Don't go away. Give me a minute, please. I have a phone call. 1 minute.
Okay, I'll give you a minute. How many minutes do you need?
All right, I'm back. So, what are you saying, Sammy? Oh,
If
sorry.
men don't,
So do you think that? So you
Okay.
want to take away women's right to vote? Really?
well, I would say you should give men the right to vote, not take away women's right to vote.
A woman? No, they're never gonna do that. Never.
Well, it doesn't matter necessarily what like the outcomes are going to be. It's a matter of principle in this case. I'm telling
No,
you
no,
what
no. Men
my
have the
preferred
right to vote
outcome
as
would
well,
be.
but women have the right to vote as well. I'm saying like
Right.
women cannot go to war. You know,
Guys, one
Oh,
second.
why can't women go to war?
because they're women. Basically, if we send women to war, then they're gonna get essayed and impregnated, and the people that impregnate them are gonna send them back here with our baby, with their babies, and they're gonna demoralize our country, and we would not allow that to happen. That's literally what China did. That's what was gonna happen if we
Okay,
send women into
wait.
war.
You say your point?
Yeah. So frontline combat, right? Only men can do frontline combat. The USA does not let women ever do frontline combat and never will, because if we do, then they're gonna get impregnated, they're gonna get essayed, and they're gonna get impregnated, and
How
then
does it
once they
follow if they serve frontline combat, they're going to get pregnant?
well, because that was that's pretty much the enemy's plan.
So
And
the
we can't
enemy's plan is instead of engaging the enemy in a firefight, they're going to what? Rape all of the women?
pretty much, yeah.
Wait, one second. So,
Sex.
I
wait,
don't
wait.
see any like
Can I interrupt
proof
one
that
second?
that has been a thing that has happened
Wait, one second, one
or
second.
would be a thing that would happen.
So, in my opinion, that would be the best thing if it would happen, because I mean, obviously not for the chicks. I mean, I'm against obviously that, but if it ends up happening that American women are going to get pregnant by the enemy's soldiers, then guess what? Now the enemy
Oh,
has an interest in the welfare of the children because it's their children. So now it's going to
bro, they don't care. Are you?
wait,
Is that
wait,
really your argument?
wait,
They're not
wait,
gonna care. They're
wait,
they're
wait,
bad guys.
wait. I didn't finish. Wait. So because it's their children, they're going to be interested in the welfare. So that will actually incentivize peace. Actually, that's exactly how the Romans used to create peace. So they used to like conquer someone, and then they said, "Okay, give me your son. Your son goes to Rome to be educated as a general, and I'm leaving my son with you, and he's going to be your general. How about that?" So you force whoever you conquer, you force them, whether they like it or not. But this is part of the peace treaty. This is part of the terms of the surrender, that you integrate, you intermarry, and you create incentives, and this way you actually incentivize peace. This is as peace can be incentivized as possible. Like if you want maximum peace, that's how you do it, through
No, that's not true. Japanese, dude, that was literally Japanese strategy, and
Mhm.
that's how they beat China. By using that strategy, impregnating their woman, sending
The
them back, and then America
Japanese.
was just like,
Okay.
yeah, Japan, bro,
No,
yeah,
I don't know. I don't know. Anyway,
and
I
then
know.
America was,
Look, I know that the Romans did it, and it worked for the I mean, the Roman Empire lived for like a million years. Like, if you
bro,
want
we can't take that risk, brother.
to look, if you want to reproduce success, learn from the Romans. No one did it better than the Romans. Anyway, let's get back to entanglement.
Okay, so like
Mm-hmm.
the thing that I would say in
Mm-hmm.
relation to this
Mm-hmm.
is just because you could do math that leads
No,
to a graph that looks like
there's no
another
math.
graph.
There's no math. Well, why do you keep
Well,
bringing up
you're
math?
running it through a computer program. The computer program is doing some form of math,
Yeah.
isn't
Okay.
it?
Okay. Yeah. Sure. Mm-hmm.
Right. And just because that computer can create a graph mathematically that looks similar to another graph, it doesn't mean that the first graph, like or the original graph, the one that's talking about quantum mechanics, is not correct. It also is a graph that comes from like collecting data on an experimental outcome. What was the experimental outcome that this demonstrates? That your graph demonstrates, I mean.
Look, the whole point is that they claim that you need telepathy between particle 1 and particle 2 in order to
Right, to
recreate.
explain the outcome.
Yeah, but look. So they ran an experiment and they got the black dots. And they say the only way to get the black dots is through telepathy. And I'm able to recreate the experiment without telepathy. Recreate the black
Did
dots.
you measure quantum particles?
No, they already. Everybody agrees that an experiment has been conducted. The question is
Right.
how. The question is how can you explain the results? There's two ways to explain. One way is right. There's two ways to explain. One way is through telepathy. If you assume telepathy, then you draw the red curve. Fine. The other explanation is if you assume hidden variables, then you draw my blue line. So I'm able to recreate the data.
If you assume hidden variables, they show you what the expected outcome is, and it's the straight line.
But I did the same, and I just did cosine squared, and I got the curved line. So I don't know why they didn't do cosine squared. But if you do cosine squared, you get a
But
curved.
does cosine squared like actually represent the experimental outcomes?
All you need to do, again, listen. An experiment has been conducted. Everyone agrees there's one experiment. That's it. It's been conducted. There's two ways to explain it. One is that there's telepathy, and the other is that there is no telepathy. There's something else. So with telepathy, they say they create the red line. Without telepathy, I say I create the blue line, my blue line. So I'm able to reproduce their line. I'm able to reproduce the data. So if the
What
particle.
does your data show?
No, I don't have data. I'm able to reproduce the data. I don't have data. They don't have data. There's two sides that are trying to explain the data. The data is given. 1 second, I gotta take a phone call. I'm sorry.
It would be a lot easier if I knew what like the math the computer is doing. Just like, is that what the math is?
Okay, I'm back. Can you hear me?
Yes, I hear you.
I'm sorry, yeah. Uh, yeah, so do you understand my point? So let's repeat or let's recap. So there's an experiment has been conducted, and we need to explain the data. There's two ways to explain the data. So one person says, well, there's two ways. So one option is particle one is communicating with particle two, and that's how you get the red line or the black dots, because they're talking to each other. Another option is they're not talking to each other, and they don't need to talk to each other. There's no reason for them to talk to each other. It's predictable. It's predictable, and we run the and we write the code to reproduce the black dots to show that given right if we look at the code, let me screen cap the code. I know you don't you've never seen code. You've never seen code before in your life?
I've seen code. I took like a programming class. I have a gist of what like it looks like. Like if you showed me code, I know I'm looking at code. I just don't know how to decipher the code.
Oh, okay. I'll
That makes
explain. I'll explain to you. It's very straightforward. Um, you just need to understand literally three lines. I'll paste it. I'll post it. I'll post it in the side chat. Okay. So let's go over these three lines. Literally three lines. So it's a function. You see def. Do you see the word def? Are you there?
see angle diff.
No, def. DEF. The first word is DEF in blue. Do you see it?
Yes, I see it.
Okay. So that just means, I guess, define. So define measure. Measure is a function that belongs to the particle. So you tell the particle, you ask the particle to give you the measurement, and you pass a parameter angle. You can ignore self. So when you ask particle one, first you ask particle one, and you give it the angle, and then if particle one gives you zero, gives you up, right? It returns the function. Look at the last line. It returns either up or else it returns down. You see the last line?
Right.
Okay. So measure, when you ask a particle to measure itself, you give it an angle and you ask it, okay, that's it. That's all you know. You just know the angle. That's the angle of the measurement. That's the angle in which the experiment is being set up. It's basically a magnetic field. That's the way we're testing the particle. So that's the angle of the magnetic field. So we're telling the particle the angle of the magnetic field, and we're asking the particle to measure itself relative to the magnetic field, and just tell us, are you up or down? Okay? So far, so good?
Okay.
Okay. Now, internally, the particle has look at the first line of code. It says angle underscore diff equals ABS, that's absolute value of self dot hidden angle. Self dot hidden angle, that's the hidden angle that the particle has. Right? You could say that's the hidden variable, the hidden angle. The particle, when it was created, it was given a hidden angle. That's the angle at which it is spinning. That's the spinning. That's the spin. That's the particle spin that we can
Right.
never know what the actual particle spin is. All we know is when we measure it, we know is it up or down relative to a magnetic field. So far, so good?
Okay.
Okay.
Right.
So the first thing that the particle does is, or measure, when we tell the particle to measure itself relative to the angle of the magnetic field, is it calculates the angle diff. Angle diff is the angle difference between the hidden angle and the magnetic field angle that we passed it as a parameter. Right? It says self dot hidden angle minus angle. That's the difference between the hidden angle that the particle, that's the spin of the particle, minus the angle, that's the magnetic field, that's the apparatus. Are you following so far?
Why is quantum entanglement bullshit?
Well, we're discussing it right.
Kinda.
You're kind of following?
I'm having a difficult time following.
Look, the
'Cause,
point
like,
the point is that, right, I understand. Look, the point is that there's no information sharing between particle 1 and particle 2. Particle 2, right now we're particle 2. We've been asked to measure, are we up or down, and all we know is the angle of the measurement and our angle of spin. And it doesn't matter, we do some calculation, which is the cosine squared of the angle over 2. It doesn't matter, we do some deterministic calculation, and we tell you, are we up or down? And we reproduce the data. So we are a viable theory. This in front of your eyes is a viable theory to replace the teleportation, the telepathy theory. Right? You're telling me that using telepathy you can explain you can also predict correctly up or down. But I tell you, I can predict up or down without telepathy. Do you understand that?
okay, but have you tested this in an experiment, or did you just run math on a computer?
No. The experiment has been done. The experiment has been done. We're just trying to come up with an explanation to the experiment. And there's two possible explanations. One is telepathy, and the other one is not telepathy. Both explanations are viable. They both give you the same graph. Right?
Okay, so like, have you shown this
What?
to someone who studies quantum entanglement professionally?
Yeah, it's not gonna be hard to get in front of one of them and ask.
Okay, right now it's me and you. Right now it's me and
It's like, if
Sammy.
it's me and you,
Why don't you put
I
this
am a
together,
blithering
compile it, and get in
moron.
front
Why
of
do you
one?
sound drunk?
I'm a
Yeah,
blithering moron. when it
Guys,
comes
compile
to
this
these sorts of
together and
stuff.
get in front of somebody that studies quantum entanglement
Okay,
theory.
okay.
I mean, look, it's
Okay.
really not hard to get in front of those people, guys.
Okay. But that would be appeal to someone who studies. I don't want to appeal. Right now we're debating.
Well, no, I'm saying you're gonna have more fruitful discussion
You
than
don't know
speaking
that.
to some person.
You
I
more
do know
likely
that.
would.
Okay,
He
so
would be able to explain
so
to
I
you
don't know what you're talking
why
about,
Slave mail, are you
visual
and
intoxicated by
therefore,
chance?
look, I don't know what you're talking about when you were talking about this quantum shit. Therefore, I cannot have fruitful discussion because I would first need to study more about it. So I can deduce from that if you talk to someone who's an expert in
Okay.
this, you'll
Mr.
probably have more fruitful discussion. You'll have a more interesting debate.
Mr. Halal, whatever. Okay.
Pretty simple.
Yeah. Thank you. But right now we're having an actual discussion about the actual topic. So please don't interrupt. Either you're welcome.
Just don't interrupt. Well,
You-
what a dickhead. I mean, look, it sounds like he said the same thing I said to you.
No. You're welcome to interrupt with actual comments. But if all you're gonna tell me
Yeah,
is,
that is an actual comment. I said, hey, it would be a good idea.
and we're done.
Halal, you just got silence, mate.
You can get some good
I'm
insights
not
if you
interested.
do what I said.
I'm gonna
It's an
mute you
idea.
if you're
Why
gonna.
are you
I'll
muting?
mute because I'm not. Either we have.
You are intoxicated.
Okay. Thank you. Anyway, Sammy,
My main thing here is like, why add cosine?
it doesn't matter. It doesn't. It doesn't.
No, but it does matter.
No, it doesn't. Look.
Because there's a lot when it comes to
Slave, I
quantum
think you should go
physics
to
and
beta,
quantum
fella.
mechanics. It's not just what the simple video simply explained. Just because you can recreate a graph that looks similar doesn't mean it experimentally like demonstrates anything.
No. Again, the experiment has been done. We're trying to explain the experiment. In order to explain, a good explanation reproduces the data.
Okay, but why does this explain it?
It reproduces the data. What more do you want?
It
That's like
reproduces a graph that looks the same. It
the
doesn't necessarily reproduce data.
what? No,
What explanatory power does this have?
there's no telepathy. You don't need telepathy. Right? You're coming
Like
to me.
it's
You're coming to me with the literally the most outlandish theory. The theory that of telepathy, that the two particles are communicating um, instantaneously. That's also a violation of relativity. You're telling me that you're violating the laws of nature, and you've come up with telepathy between particles, which then they're also intelligent. Anyway, this is outlandish. And you say, yeah, I can reproduce the data.
okay. Again, if you're finding the claim to be outlandish,
Not the
you
claim.
need to disprove the claim.
Right. So I'm saying no. I mean, there's two alternative theories to explain the data. One is telepathy, and the other one is not telepathy. That's all. Both
Well, you were
reproduce the
saying
data.
it's telepathy.
What?
It's not necessarily telepathy.
What?
It's quantum mechanics.
No. It's
Do you know quantum mechanics?
okay. Let's not discuss me. So one option is that the two particles are
It's about like what we're discussing is quantum like mechanics. Do you know quantum mechanics?
Okay. We're not
If you
discussing
don't
me.
know quantum
We're not
mechanics,
talking
how
about
can you
me.
say it's wrong?
I'm not saying it's wrong, and we're not talking about me. And I can say anything I want. Stop it. Where are you going with this?
Oh, I
Listen.
know you're free to say whatever you want,
Yeah. Let's talk.
but it's about whether or not you're like correct,
I don't know what
whether or
that
not you
means.
have valid reason.
Asking questions. I mean,
Like, I don't think there is any reason to believe that your stimulation
mhm.
has any more like explanatory power over what like scientists are like postulating.
Look, there's two ways to explain the data, right? One is that every time you measure particle 2, right? Particle 2 doesn't know what to do. When you measure particle 2, it doesn't know what to do. So it communes with particle 1 telepathically, instantaneously across the visible universe. And particle 1 gives it the answer. That's one explanation. Another explanation is not. Is exactly the calculation that I showed you, that the particle does the cosine squared of the difference of the angle divided by 2, and it knows the answer. It doesn't need telepathy.
Why add the cosine?
It doesn't matter. There's no need for telepathy.
does matter.
No, there's no need for telepathy. Listen, that's not the point. There's no need for telepathy. I don't need to explain to you exactly what I fit the data. It does something. It's because of
You're calling it telepathy. It's not telepathy.
fine. What? Still, it's a violation of the speed of light. It's at least a violation of the speed of light because they tested it and it works instantaneously across vast distances. So
Right, which is the case whether or not, because like it's a matter of like information.
no, that's only according to the explanation of that's called spooky action at a distance, what I call telepathy. It doesn't matter what you call it, it's magic. It violates the laws of
It's
nature.
not magic.
It's fine. It's a violation of relativity. It's a violation of the speed of light. We've never seen anything moving faster than light. So you have to violate
Nothing is moving faster than light.
information. It's a violation of information moving faster than light.
Right.
Yeah, that's that in itself.
What does that cause problems with?
No, there's two ways to explain. There's two ways to explain the data. One is call it whatever you want, spooky, telepathy, violation of nature, speed of light. I call it telepathy. You don't like it, telepathy? Tell me what to call it. Give it a name. One is
It's called quantum entanglement.
no. Quantum entanglement
That is what it's
no.
called.
The two particles are entangled because they are entangled because they have opposite spins and they give correlated measurements. That I agree with. The measurements are correlated. There is
That's where the
entangle.
quantum comes in.
No. The quantum entanglement, that's the phenomenon of the measurement. The measurements are correlated. That's a given. That's
Well,
the
no, that would just be entanglement, not quantum entanglement.
No,
That's what quantum is for.
no. Quantum entanglement. Quantum entanglement is the black dots. Is the experiment. No one denies the experiment. There is quantum entanglement. The question is it spooky action at a distance? Is it spooky? Is it telepathy? Or is it not? So there's two ways to explain the black dots. There's two ways to explain the data. One is with telepathy or called whatever you want, and the other one is without. That's all I'm saying. Both can reproduce the data. That's all I'm saying. Telepathy, of course. If two particles have telepathy, of course, particle 2 doesn't know what to do. It calls up particle
I
1.
don't think there's necessarily any like positive like discussion that can be had here in relation to it, because like both of us are laymen's here. You would need to talk to a professor of quantum like mechanics, and
Okay.
he would be able to
So
explain to
you
you whether or
so you
not it was
concede.
or was not an
So you're
explanation.
conceding. That's a concession.
In the sense that like I don't think I could convince you, and I don't think you could convince me. Yeah, do I think you're right, and do I think it like me conceding demonstrates you're right? No.
No. You're conceding. When you appeal, when you tell me to talk to somebody else, you've conceded.
Yeah.
You concede that.
But that has no bearing on the truth of your argument.
Yeah, you
because again, I'm a layman
conceding.
here. I have
Okay.
no actual
That's
understanding of quantum
that's conceding.
mechanics.
That's conceding with many words. You're still conceding.
Well, yeah, I know. I've already acknowledged that I'm conceding, and I'm just adding the words, which I am free to do.
Anyway, look, I sent you a friend request. I think you're a smart guy. Either way, you're good to talk to.
Okay.
Come visit my server. Wait, what? Your message could not be delivered? Wait, you didn't answer yes.
I did not answer yes to friend requests because
Why?
I don't tend to answer yes to friend requests unless a rapport is built with a person.
Stop it.
I don't know you very well. In the future, I may know you more.
So come visit my server. So you can always unfriend me. What kind of who does this? Why don't you want to be my friend?
What do you mean?
I want to invite you to my server so we can have fruitful discussions.
Where I don't want to be on another server.
So
I'm
you
fine being on this server.
okay? Anyway, it's up to you. Okay, I'm gonna unmute Mr. H. Mr. Puppy, do you wanna Chris Henke? What? Mr. H, Mr. Halal? Is he not alive? Did he leave? Is he away from keyboard? Amber, can you talk? Oh, we have comments in the comment section. Don't delete my comments and put it in dumbass ones. What? No one ever sold being. There are no straight lines in quantum worlds. What is going on here? Buy silver, platinum, and crystallize osmium. What? What is going on? What? Oh, this is from an hour ago. Everybody's gone. Anyway, but this graph, okay, it makes sense. Okay. At least everything makes sense now, except for quantum entanglement. The fact that I can reproduce the graph, that's all I need to know. Okay. All right. I'm gonna take a break. Let's cut the stream. Yeah, I'll cut the stream.